Aboli. Hello, am I audible?
You
Yes.
are.
Yes.
Yeah.
Anand.
I am here.
Ankur.
Yes, ma'am.
Arvind. Ashish.
Yeah, hi Shivika.
Hi. Ashutosh.
Yes.
Cheryl.
Hi, Shivika, I'm here.
Harsh.
Hey, Deepa, I'm here.
Karthik. Poonam.
Oh, yes, Shilpa, present.
Ravi.
Hey, I'm here.
Rilesh.
Yeah, I'm.
Rushikesh.
Hey, hi.
Rutuja.
Yes, ma'am, I'm here.
Shubham.
Yes, I'm here.
Siddesh. Tina.
Yeah, hi.
Vaibhav. Pratik. Dharini.
Hi, Shilpa, I'm here.
Okay, I'll retake the attendance. I'll review it and mark them present if anybody joins in later. For now, Shrikant, we can start.
Thanks, Shivika. Good morning, everyone.
Good morning, Shikha.
Good morning, Shikha.
Okay, can you quickly complete yesterday's code? I see a couple of you have not completed that. Quickly complete that. If you have completed, let me know. Okay, so we are writing a simple producer. I shared the code with you.
Can you reshare again, Shikhan? I didn't lost the chat.
Okay, just hold on. This is my simple producer. I'm sharing complete main method, okay? I doubt. Okay, fine. Yeah. So the topic we had created is test 3. Now, what you can do here, you can create one folder here in Kafka training. Let's say folder as scripts. Okay. And let's create files here. Those who are not, completed code, first you complete a code. Those who are completed, follow me. Okay. And the others who are writing code, don't worry about this. What I'm doing right now, we'll share all the scripts with you readily, and it's readily available, for you then. Okay. So I'm creating one file here. Let's say zookeeper.sh. Okay. All right. Now, what is that command? Okay, what we can do here, we can go to the terminal, right? And zookeeper server start.sh, right? Then home Kafka home, right? Then bin, and then sorry, not bin, config, right? Config is not coming here. Okay. All right. So how we refer a home? Right, Kafka, and then config. Why config is not coming here? Kafka. All right, fine. So
we need to go inside the Kafka first, right?
okay, we are in home Ubuntu, right? So zookeeper server start.sh, then Kafka home / config, right? And zookeeper.property. It's not coming here automatically.
Can we do like Shrikant? As of now we are in the home Ubuntu. So can we go inside the Kafka folder first? The symbolic link.
See, basically we can do that, right? But here we are using some shell scripts here, right? So we'll keep it something like this,
Okay.
Let me see if it works. Okay, install. Now it is asking me because it has recognized that I'm writing a kind of a shell script. So it is asking me, prompting me to install something kind of a plugin for a shell script. So I'll say install. Can you see here on the right side?
Okay.
Install it. And it is installed. Now you can right click on this and you can start your zookeeper. Let's see if it works.
Okay.
All right, right? So something is wrong here. But is invalid config. Okay. Let me remove this. Home Ubuntu Kafka config zookeeper.properties and try again. Okay, I guess it is already running. Yeah, okay. All right, fine. Let me kill that. Kill -9 to 876 to 876. Okay. And I'll try running this one more time here. Okay, all right. Similarly, you can create a scripts for other commands, right? So I'll rename this as rename this. There is a refactoring here. The first thing we are doing, right? So let's rename this as a 001 here. Okay. Okay. Then second is what? Second is broker or 1.sh, right? Broker 1. So let's call it 00002. 002. And what is the command? Let me copy this because we'll require this. Okay, so here it's a Kafka server start.sh. Here it's a server 1.properties. Now some of you have done underscore here, so make sure you make changes, corresponding changes here. Okay, in my case, right? So I'll copy this and new file.
You have to remove one dot properties. Server one dot properties.
No, in my case,
No,
it is
no,
correct.
there is a in command server one dot properties dot properties.
Mention properties twice.
Yeah, yeah, I'll remove that. I'll remove that. So 002 underscore broker 02 dot sh dot sh. Okay, 003 now here. So it's better to have some sequence there. All right, right. So remove this properties from here, and here it is 2. Okay, I'll add one more file here. File 004 and broker -03 dot sh. Okay, this and then 3, go to the 1, remove this properties here. Okay, let's start running this 3 servers now. It's very easy here, right? Rather than going to the terminal and starting a lot of windows and then it's some all mess, right? So we don't know which terminal for what service. Okay, so this is better. So right now you can see your Zookeeper is running. This is your server 1, server 2, all right, server 3, all right. So everything is running. Go to terminal. Go to terminal. You're already there in a terminal. You can add any terminal. If you want one more terminal just to check what all services are running, click on a plus sign and check your JPS, right? You can see your 3 Kafka servers are running, 1, 2, 3, and your Zookeeper is also running. If you don't want, you can close this. All right. Now you can have some more scripts now here, right? So maybe you can say file 005. Maybe I would like to have to create a topic. Topic, create a topic.sh. All right, so here I'll say Kafka. So I'll go to this terminal and then Kafka topic.sh, create topic name, right? So I'll say topic name. I'll keep it generic now, and then Bootstrap server. Right, there are some plugins available where it will add to complete Kafka commands for you, so you can explore that, but things are there. Okay, so you don't have to type Bootstrap. Even it recognizes that you are trying to use this property Bootstrap, it will add to complete for you. Bootstrap server, I'll say localhost :2 okay, and then partitions 3, because we have 3 servers, and a replication factor. Replication, let me know in case of typo, guys. Okay, replication factor 3. All right, are we good here? It looks like, right? Create topic Bootstrap server. All right, copy this and add here. Okay, fine. Right, so we can say a T1 now, topic T1, and it should create that topic T1, right? Right click here and run create topic. Easy here, right? If you want to describe and something like this, you can use this command and copy this, right? If you want to describe, so I'll say describe, right? Topic T1, and we don't need other details when you want to describe a topic, just the Bootstrap servers, but you can comment this here, right? Because you are planning to create a here, right? So if you want to list all the topics for whether the topic is created or not, you can copy this, right? So whichever command you want to fire, just uncomment it. Others you comment it and run it. Okay. So here I'll see, instead of describe, I'll say a list here. Okay. So I don't want to run first one because you're already done. So I would like to list all the topics created so far. Right, so we have test one, test. Oh, why we have only one here? A list topic T1. Okay, fine. So when you say list, you cannot specify one topic, right? So you would like to see all the topics there. All right, so it looks good, right? So far we have created three topics, if you remember, and then today we have created T1 here, right? You can always delete a topic, right? So you can also have one command here. So delete, right? Delete, and then topic name, say T1. Okay, so comment first one and run this one. It won't delete it immediately, right? It will disable it for some time, and then it will delete. Mark disabled, right? So now if you comment this, and if you uncomment this, right? So you should not see the T1 now. All right, you can see your T1 is deleted. All right. So yeah, so similarly, so you would like to add some producer also, right? So I'll say console producer. Everything you can do from here only, right? You don't need to go to that terminals, producers.sh. Okay, so I'll use terminal here. Kafka console producer.sh, topic name. Okay, then Bootstrap server localhost :9092. Okay, is there anything else required here? Is there anything else required here? I think no, right? Topic and Bootstrap server. If you want key value pair, you can add that. Okay, so hyphen property pass is equal to true. Okay, so you can copy this. Yeah, tell me what are the properties, guys? Who will tell me? Property parse key is equal to true, and then
Property key separator.
property key dot, what is the spelling?
SEPE.
ERATOR.
It's PA.
PA.
I got an error last time.
Separator.
Yeah.
Is this fine?
Yeah.
So that will go in a double quote, right? So this is another way. So for now, I'll comment this here. All right. Similarly, you can, have one more script here. Console consumer. Console consumer.sh. Okay. So let me go to terminal. Console consumer.sh, topic name, and then same thing will go there. Okay, because we will require this files, right? We'll not be wasting time on terminals, starting tab, and then all those kind of things. Okay, so here I'll go to the topic quickly and I'll create a one topic here. Don't put me on speaker, guys. It's echoing. Okay. So I should comment this. I should comment this as well as I should comment this. I should uncomment this. I'm creating one topic T1 here. I'll quickly show you how to use console here itself. So I'm creating T1 again. Right, T1 is created. So producer, right? So producer topic T1. Right, let's run producer. Okay, you got the prompt here, and let's produce M1, M2, M3. Let's run a console consumer and add one property here from beginning. Okay, and topic name is T1. Don't forget that. Right, let's run this. So we should get this through 3 messages, right? M1, M2, M3, you can see here, right? Very simple. So you can see what's going on here. You can see here, right? So if you want Zookeeper on the left side, you can, okay, I cannot ship this. It's okay, fine. So you can see what's going on here, right? This is the local terminal, you can delete this. This is local terminal, you can delete this, okay? All right, fine. So now what I can do here, can I share these scripts with you? Looks difficult. Okay, so that's fine. So you can simply add this now here. Okay, create a files. Let me share one by one. Okay, this is the first file. This is a broker 1. Okay, then broker 2. Okay, then broker 3. And this will help you, when you are working on a Kafka, right? This will help you. Okay, then create topic. Create topic. Okay, so then console producer. Console producer, console consumer. I think earlier was a console consumer. Okay, I made a mistake there. So console producer, console producer. Yeah. Okay. All right. Complete this folder, and whenever you create a new folder, new project, right? Simply copy this folder. You open both the projects, copy this folder, and paste into your new project at the project level, guys. Okay. So, all right. So are you done with the code now, guys? Convert example. Tina, are you able to complete that now yesterday? Is it working now? Okay. What was the problem?
No, actually, I created a fresh Maven project and then it was working. It was able to download the dependencies.
Okay, fine. All right. So now, any questions here before we? So quickly complete this activity first, creating the scripts folder at the project level. Okay. So right click here and say new directory, name that as scripts, and just create all those files here. It's very handy.
Will you be able to copy the script folder itself?
From one project to another. If you are asking me, can you copy this folder?
Copy this folder to chat.
I doubt. Let me try this. It's not allowing me. No. Okay, Control C, Control V. No, Control V is working for the last copied thing, not entire folder. Yeah, it's not working.
Okay.
It's there on the chat box. All the commands are there. Right. So a couple of things were completed here.
Hey Shrikant, can you open the IntelliJ? I need to
Sure.
name the files.
Yeah. Yeah, it should work. I don't know why it's not working. I not tried, but it's okay. It should work. I shared the screenshot of all the file names, how I'm naming them.
Shrikant, for Spring Boot also, do we have the similar, similar way, in the similar way we upload, produce the events, or it's different
See,
for Spring
basically,
Boot?
when you are using Spring Boot, right? So it is more, I would say a rich API set, right? So there are slight difference, concept-wise it's exactly same, right? But then there are some, some other APIs coming from Spring Boot, and then that will reduce your code base to a good extent when you're using the Spring Boot.
Okay.
Let me know once you're ready, guys.
Hey Shrikant, need your help. I have copied the script, but the prior code base I am struggling to complete.
Okay, share your screen.
Bit behind. It is visible?
Yeah,
Let's see.
you can share your code. Yeah, it looks like mm,
No, one second. I need to copy this to the simple producer, right?
yeah. Okay. You'll have to import all this kind of thing. Can you open up your external libraries on the live site? Do you have a JDK downloaded there? JDK should be there, Kafka. Okay, collapse that. I mean, you do not have a Kafka API, right? So you'll have to go to your pom.xml. You were there yesterday?
Yeah, I was there, but I couldn't complete this part.
Okay, fine. See, the dependencies is missing. I'll share dependencies quickly. Let me go and pom.xml. You can add this after properties. Add this after properties. Line number 15.
Should I stop sharing?
It's okay. Don't stop. Quickly we'll complete that activity. After properties, start sharing, Ashish.
1 second. I'll just
Sure.
copy this dependency.
How many of you are able to complete this activity, guys? Could you please raise your hand quickly? How many of you are able to complete this activity? Writing code and running code properly. Ankur, Pratik, Anand. Then Siddesh, Shubham. Okay, please complete this. See, basically, at least some base code you should be ready with. Okay.
Yeah, that's why if we lag behind and we couldn't
Yeah,
compile
you won't be able
database.
to catch up then. Okay,
Yeah.
you'll find it difficult.
Yeah. So where should I add that? I copied the dependency.
After line number 15. After line number 15, press enter and control V. All right. And on the right side, you see some icon here. Click on that. Right. So you can see here now it's downloading here.
Shrikant, one thing I noticed that whatever content pasted on chat, I'm not able to copy to this cloud desktop.
Okay.
I don't know. Yesterday it was
Which browser you are using?
Chrome.
Okay. It should work. It should work. Okay. So there might be some other issue. It's working for everyone. It's working for me as well. So maybe you can try some other browser if it.
No, yesterday also it was working. Let me see if I try to copy somewhere else. Not sure
You
why.
can't copy the commands. You can copy the content, I guess.
No,
No,
what do you mean by that?
yeah, so
You should be able to copy the text what I'm putting on a chat box.
Yeah,
So
that's what I was trying to, but
Hmm.
I don't think it is being copied.
So if
so
you see on the top right on the URL bar, right,
yeah,
that clipboard icon is that enabled? So if you see, or even on the shared screen on the top right, on the Chrome URL,
Yeah. What's that? Oh yeah.
there's a clipboard icon, right? That should be
Like,
enabled for your tab.
let me try that now.
Next step, Shrikant, what should I do after the dependency?
Yeah. Now you go back to your code and try importing things. It should work now. Simple producer. You can close this window, all the other windows main.s. All right. So just mouse over on properties. Import class. Yeah. Then producer config. Mouse over on producer config. Since your Kafka is a part of your dependencies, right? String serializer, mouse around that. Right. So similarly, you import all the classes what you are using there.
I think I'm done.
Yeah, so there's no error now. So I hope your Zookeeper and servers are running topic is there. You mentioned topic test 3, make sure topic test 3 is there. In the topic 005, right? So I mentioned all three options: list topics, describe topics, create topic, delete topic. Everything is there, right? So if it is not there, you can create a topic.
So yeah, that only. So Shrikant, I yesterday tried doing the JPS, but I was not able to get the list. Like, so once we close this window terminal, it gets close or what? Server gets down.
If you close window, which window? Where your Zookeeper is running?
Yeah.
If you close any window where some services are running, obviously when you close that window, that service will be down. You're shutting down that service. You're supposed to keep it running there. Then only maybe you can open another window and there you can fire a JPS. You will see what other services are running. Okay. So now you can maybe you don't need these windows now. You can close these windows, and if you want a terminal in the Eclipse IntelliJ only, we have one tab for terminal. Open it and you can fire JPS there itself.
In the IntelliJ, right?
Yeah, there's a one terminal here. I'm marking here. Right.
Okay.
Maximize the window. I'm not able to see what is there in the terminal. Yeah, you can see there, and you can type JPS there now. Right. So you are not started any service there. Okay. So you are yet to start Zookeeper and all three brokers.
Okay.
So right click on Zook. Yeah.
From here itself, I can start right now.
Yeah. Right click there and you can start. User run 001 ZK. Yeah. It's running. Then server 1. Okay. Can you show me the error now? Double click on that. Probably your file name is server and hyphen 1 or underscore 1.
Underscore 1.
Yeah. So change all those files one by one. Yeah. Double click there. Double click on that file. Yeah. Change it to underscore 1. And also install it. It is asking you, would you like to install a spell check to verify? It's okay. You don't need to install this. Server underscore 1. You can say no there. It will keep on prompting you. Okay, then second. Underscore. Others 4 or 5 guys, you can see what he is doing, and you also please complete this. Yeah, try running your first broker now. Yeah, I guess it's running, right?
Yes.
Double, yeah, right click on broker to run. All right, broker 3. All right, then double click on create topic. Test 3 is created, right? Or not?
Test 3 yesterday I have created. Can
Okay,
we
fine.
check?
So you comment that line control slash comment first line, yeah, control slash anywhere you can, just not yeah, and then uncomment line number 3, control slash, yeah, and run this. No, uncomment that.
1 second.
Control slash. Use shortcuts. Yeah, right click there and then see test 3 is there or not.
I'll run it.
Yeah. You should have test 3 there. Okay, test 3 there, right? So now you can run your producer now. Right? So, no, not this. You have written a code, right? So we'll not use the
Simple
console
producer.
producer.
Okay,
Yes, we'll run a simple producer and go to a line number 007 file number console consumer, right? So we have not written a console consumer using the Java now, right? So here we can say topic test 3. So to see the messages, we'll use a console consumer here, and to produce, we'll use a Java code there. Yeah, very good now. Right, run a simple producer. And run this code. Is already shared Anant on chat box. You can check that. You want me to send again?
Failed, I guess.
Hmm?
It failed, I guess. Failed
Check.
to load class static log binder.
No, that is a warning. That is a warning. Okay, so run a console consumer now. How many messages you have pushed? 49, right? 50. Yeah, run this.
Shrikant, can you please share again? Actually, I
And-
disconnected in between, so I lost the
yeah.
previous chats.
Fine. So who is this? Who is sharing screen?
Ashish.
Ashish. Are you good now?
Yeah, I'm good.
Okay, cool. Right?
Thank you.
Stop
Thank you.
sharing. Yeah. Let me share that again. Can someone do that quickly? Okay, let me share. It's time consuming, guys. So what happened now in my case it is not working.
I'm sharing, Shrikant.
Sure, thank you. Okay, what is this? CL. C. This is L, right? It was working yesterday and it's not working
Yeah,
today.
Shrikant, you are not shared anything. Your screen is not shared. Yeah.
Are you able to see now?
Right.
Okay. Okay, what is this? It's a C L O D K CAF D capital D K A F K $1 K$1. Okay, fine. So now understand here. Okay, let me go to this. So we are done with this basically, right? We are done with the installation part and single node and multi-node. We are done with the multi-node on a single machine. If you want to have, if you have a multiple nodes, then you don't have to create a copy of server.properties. On every node, you will have only one server.properties, and every machine, every server.properties will have the same configuration except the broker ID, right? So on the first machine, on one machine, it will be broker ID 0. On another machine, it will be broker ID 1 and 2 and 3 and something like that. Okay. So you don't need to change your port number to 9394, right? Because every machine has a unique ID, right? You can run one service on a multiple machines, but you cannot run a 3 services, of same type on the same port. That's why we change our ports to 9092 to 93 to 94 that way. Okay. And of course, when you are every individual broker is running, it should have its own log, right? You cannot have a common log. When 3 services are running, every service should have its own log, right? And that's why we, in a log basics, there is a one section in a server.properties, we change it to Kafka log 01, 02, 03, something like this, right? But if you are configuring your Kafka on multiple nodes, then you don't need to do those kind of things, right? Because every machine, every service will be running on an individual machine. Okay, so that's the major difference between this multi-node and single node cluster.
Shrikant, I'm
Yeah.
so sorry to interrupt you. Just one question I have. So, as a part of this exercise, which we, like recently done, we created 3 brokers, right?
Mm-hmm.
But the consuming and producing, which we are doing, that we are doing only with the 9092 broker,
Okay.
right? But as we have given the partition as 3 and the replication factor as 3, then ultimately the other brokers will also come into the picture, correct?
Right. So what is the question?
So suppose like if we mention the, like in consuming or producing, if we mention other broker, suppose like localhost 9093, then also we should be able to get all the messages while consuming consuming the topic, right?
Yeah, I'll explain you. Give me 2 minutes.
So Srikant, by Bootstrap server, are we connecting with the broker server cluster, right? Not a particular broker.
Yeah, right. So whether it's a console producer or console consumer or in your simple producer.java or your consumer.java code, right? This is the Java things and this is the console. Doesn't matter what you're using, right? So when you say Bootstrap server, right? Localhost 9092, right? So what actually doing actually we are creating a topic, say test 3. I created topic test 3 with the 3 partitions and 3 replication factors, if you remember, correct, right? So we know one partition is here, one partition is here, and they are replicated somewhere, right? So maybe this is your leader partition replicated to this and this, right? So maybe one leader partition is here, right? So this is replicated here. Okay, maybe one leader partition here, right? And this will be replicated to this and then this, something like this. So on every machine, the partitions are spread across multiple nodes, right? But here you are using 9092. Why? Now you might have maybe some more brokers here, right? And you created a one topic T1 here. So T1 first partition is here, second partition here, and third partition is here, right? So this is broker number 4, 5, 6, 7, 8, 9. Actually, T1 is there on a broker 5, 7, 9. Your T1 apart in a single partition, even on a replica, is not there on a broker 1. Still, we are using here broker 1, 9092. Okay, how this works? Basically, when you create a topic, while creating the topic, you are specifying that Bootstrap server, right? So whichever Bootstrap server you mentioned, you can pass on any Bootstrap server, 9092, 9093, 9094, provided it should be up and running there. While creating the topic, if that Bootstrap service is not reachable, you won't be able to create a topic. But if you are able to create a topic by using any broker, right? So that metadata, for example, like a T1, what is the metadata? That replica, the first partition is on a broker 5, second partition on a broker 7, third partition on broker 9, and somewhere we'll have a metadata for its replica also, right? Okay. All this metadata is shared with all the brokers. Okay, even if that partition does not exist on those brokers, that information is shared with all the brokers. That information is there with all the brokers. So whether you are producing or consuming or you're writing on code, right? When you say 9092, if it is up and running, this guy should be able to provide all the required information to your producer. So when you're producing, you're not producing information to broker one, but this guy broker one will give all the required information. And then what is the information? P015. So when you start producing this information, now if the topic is T1, where the first partition on broker number 5, you will start writing to broker 5 and not broker 1. This is just to get the metadata. Tina and everyone, are you clear now?
Okay.
Okay. All right. Fine. So those who have not completed, please complete that activity. Okay. So I'll proceed now. All right. So this is my first module. Let me open another module. Is more of a producer in detail now. Okay. So okay, so this is how we have written the code, right? This is theory, Kafka can be used for real-time processing, Kafka can be used for a near real-time processing, and Kafka can be used for a batch processing as well, right? So there are some examples. Now, generally, typically I cover these kind of things when you are coming from the, a Hadoop background, right? So we don't have here, so no point discussing this, but understand, right? So Kafka is not something only real-time. No, it can be used for a near real-time also. Probably those who have purchased a new car recently, not exactly very premium, but okay kind of thing. For example, like a Nexa Maruti, you see a lot of information on your app map, what Maruti is providing you. Okay, and then you can see where your car is and whether it is locked or not, whether AC is on, right? So we don't need a actually real time for this. Even if it's a near real time data we are capturing, so we are good there. So even if there's a delay of 5 minutes or 2 minutes, we are perfectly fine. So I know, where exactly my car is right now, and I can lock my car remotely by using my app. Okay, so nowadays it's all like everywhere you see, it's like if you look at this smart appliances, right? What is happening there, right? So it's all sensor-based kind of a things, and then cloud. We are using some Lambda functions there, and we are operating everything. So the thing is that they are sensors are sending data all the time to some servers, and this company is capturing all those things. And if you pay to them, and you download their app on your mobile phone, you'll be able to see all those kind of things, right? So it is not always a real time, it near real time is also fine. Let's say you're expecting some courier from Blue Dart, or so what you are expecting, right? When I say provide a AWB number, you see like where exactly the product is. So these are all basically, they might be using the Kafka under the hood to upload all this status of your courier parcels. Okay, so yeah, fine. Now, this is your code. We are done with this code. I hope you are clear here on this, okay? Now, instead of writing this information directly here, right? So we can have some class apps config. Let all the configurations, instead of hard coding here, right? So you can have some class as apps config and put all these information into the apps config. For example, like, I took topic name here itself. Right, so why to display everything in this, right? So you can write all this information into apps config, and you can refer that here. Okay, now now quickly about the producer, right? So when producer is the main instance of a producer, okay, then you get a prompt, and in the prompt, so we are sending information like key and then value kind of a thing, right? So we create an instance of a producer record. producer record has two mandatory kind of things. It must topic name and then value. Key is not mandatory. So it must include the topic we want to send to send the record to and then value. Okay. Along with topic and then message value, we can have three more things there. Okay. As a part of message, we can also specify the partition number. Now, this is something very rarely used if you are writing a producer and if you want to push messages to a particular partition, right? So you can do that. So if you want to pass on key, we can do that. We can always pass on a key, right? So we know typically key is used for the, which will be used for partitioning, grouping, and then joins. This is extremely important when it comes, when you message contains a key. And timestamp, when you are talking about real time, I would like to see things, what is happening in the last half an hour, what is happening in the last 5 seconds, right? It depends on the criticality of your application, how critical it is and how time sensitive it is, right? So based on that, this timestamp is extremely important. All right, so along with the topic name and then value, we can have three more values you can pass on if you want. Kafka producer internal SRD, custom SRD, and all right. Now, first,
didn't understand the timestamp part. What does that signify?
Timestamp basically, so when you are producing the event, if you would like to send that timing along with the message, you can do that.
Okay, so that's just one more parameter.
Yeah.
The data.
Yes. Okay. The way we are sending a key, right? We can pass in the timestamp also there.
Okay, so how does that help? As in, is there the data point, right?
See, basically, for example, say you are producing events, right? So event 1, event 2, event 3, event 4. Maybe this is going to produce, this is partition 1, this is going to partition 2, right? So eventually they will go into some partitions into Kafka cluster, right?
Yeah.
When you are consuming it, right? When you're consuming it, so while consuming, when you get these events here, right, you're going to look at the timings.
Okay, the sequencing.
Yes, you're going to look at the timing and do something based on those timing.
Understood.
Okay. Okay. So Kafka producer internals now here. Okay. See, I know. Okay. $1. If you look at this, okay, so the main thing here is this send method. Okay, when you say this is just the creating the instance of a Kafka producer, right? But when we use this producer and say send and all this record, it should not be record, it should be a record actually. All right, this is the one record. Basically we are creating the instance for each record. So here, this there are a lot of things that are happening in under the hood in this send method. Okay, and if you see here now, right, so send method, very first thing it does is serialize your data. First, producer will serialize the key and then value objects to byte arrays. It is a must. Right? You are producing key 0 and message 0, right? It's not in a binary format, it's in a string format. If you talk about this environment here, it's a string object of a class string, right? But when we store the data anywhere, we are supposed to serialize it. Okay, and after serialization, generally it takes less storage. So when you write this data, when you produce, and when Kafka writes this data into the broker in a log file, that data needs to be serialized. Now, this is string, this is string, right? So key is also string, value is also string. And that's why we are using key serializer as string and value serializer as string. It is must. Kafka will not get into your data, what data you are. Kafka will not do anything with your key 1 or key 2. It will not do anything with your message. Kafka needs whatever the data you're writing, you must serialize it and then it will go to the Kafka, right? So that is the one reason Kafka is so efficient and so fast. Okay, we are not writing the data as it is. We are serializing it and then writing into the Kafka. So first
So Shrikant, one doubt here. So you mentioned like it's a default data type is byte array, right?
Default, when you write after serializing, it's all byte array, right?
Mhm.
So it's not default, right? So whether your key can be of float, it can be integer, it can be string, it can be double, anything. Your value can be anything, right?
Okay.
But when you are passing your float, make sure you use key serializer as float serializer. If your value is of integer, right, make sure your value is serialized, your double. Let's say this is double, right? So I'll be using a appropriate serializer to serialize it to a byte array.
Okay, got it.
So in a Kafka level, it's all what key you have doesn't matter, but you need to be serialize it. You need to serialize it and then write into the Kafka.
Got it.
Okay. So even if you are not using key there, you must add this property here. That is a key serializer class config. Okay. This is the first thing Kafka producer will do when as a part of a send. All right. Next. Kafka has to decide after serializing, Kafka has to decide where this message should go. And for that, we have certain techniques there, right? So we have a hash key partitioning, which we discussed already. Then, every key has a hash code and then mod of number of partitions. Whichever remainder you get, broker will send that event to that particular partition, a leader partition. Okay. If key is absent, then things will go in a round robin. Okay. Now, in a new Kafka, things have changed a bit here. Instead of round robin, in the first place when you're sending, we have a sticky partitioner, right? So it will keep on sending events to one particular partition rather than sending things to the 3 brokers, different brokers, right? So it will maintain that, or in one go, when you fire running the producer, all the messages will go to one particular partition. There are some changes in the new Kafka. All right, you can customize your partition strategy. If you don't want that, Kafka will ensure partitioning for all your keys. Maybe out of 10 products, one product is something widely used, widely purchased. So your partitions will be skewed. Maybe one partition will have too much of data, another 9 partitions might not have that much data. So when consumer is consuming the data from last partition, that consumer is a long running process. However, others consumers are done with the processing. To avoid this, right? So you can write your customized partition. Okay. So there are different partition strategies are there, right? I talked about these timestamp, right? So for a timestamp, you don't need to add that as a parameter to your send method. In a send method, we are adding 2 things. What are those 2 things, guys? What are the 2 things? Look at your send method.
Topic and data.
You are passing key, value, and one more. What is that?
Topic,
right? So you don't need to pass this timing there. You can set one property there, message.timestamp.type. Okay. So producer config dot, what is that? Message timestamp. Can you see somewhere? Delivery timeout. Okay. Okay. So I think this is at the topic level configuration. Okay. So while creating the topic, you can mention here. So for that topic, right? So if the value of this property is 0, then a create time will be appended, will be tagged with your message when you are sending this message. If the value of this property is 1, then log append time. When exactly, I'll show you here, right? So there are 2 times here. 0 is CT create time and 1 is your log append time, right? So if you say the value of that property is 0, then when you are sending here, maybe you are sending this event at 9:47 a.m. All right. So this is the create time basically. But so of course there can be some network delay or something like this, right? So when actually this event is going and the Kafka is writing these events here as a part of some offset, right? What is the time it is writing? Okay, so maybe here because of network delay, it is a delay of maybe 2 seconds or 2 minutes, right? So here it's a 9:48, right? So this is your log when actually you're logging this event into the partition. This is your LAT and this is your CT create time, right? So based on that, what you want, okay? If you experience a lot of delays from your producer to Kafka and you don't want to use that time, maybe you can use a LAT there, when you're analyzing your data. Okay. Guys, are you with me?
Yes.
Only one person.
So this is a topic level configuration. So
this is topic level, right? So when you're creating a topic, right? So when you're creating a topic here, go to create, right? Topic, and then you can say here, right?
So here we mentioned the parameters, right?
Right. So
CT and AT.
Property, okay? Property, the name of that property and its value. Got it? So here you can specify. Okay. All right. So this is okay. Now, after producer decides on the partition, which message will go to which partition, right? Based on the hash code and the number of partition, right? After this, we have a concept of batching the messages, right? So we can match all these messages instead of sending one message at a time. There will be a lot of trips from producer to Kafka broker, and you are, it's kind of a wastage of a network bandwidth, right? So it's a good idea because generally the size of your message is bytes or kilobytes, right? So the overall size of your thing which we are sending to broker can be up to 1 MB. So you should see how much we can club together and send it in one go, right? So here we have some, batching and buffering kind of a thing. So here for topic A, I'll keep it topic A only, right? So partition 0, I'll got a couple of messages. Partition 1, I'll have a couple of messages, right? And like this here you can see. Okay, so assume this is topic A only. Okay, adds the records of adds record to a batch of records that will be sent to the same topic and then partition, a different partition. So this is your one batch for a partition 0, another batch for a partition 2, and then can be another batch for partition 3 if your topic has 3 partitions, right? And then these batches means what? A kind of a one message which has clubbed all these events together, right? So it's a one thing. So then it will be sent to your Kafka broker through your IO threads, all right? And then when you Kafka is writing that messages to Kafka broker, right? So Kafka has to respond back to the producer, right? So if it is a failure, if there is no failure, then you will get a proper metadata. The producer will come to know, hey, this particular message has been written to that partition, and what is the offset we got for that message? What is the offset number we have for that message? Everything you'll get as a part of a metadata. But if it is failing, yes, right? So there are 2 types of failures. One is a retriable errors and one is non-retriable errors. So if it is the retriable errors, it will try again and somehow it will manage to push those events to the Kafka broker. Now, what is the use case and what is the probability of or what kind of errors you might get there, right? Now, you know, for partition 0, your leader is broker number 9. All right. Guys, are you with me?
Yes.
Okay. So for partition, first partition, your leader partition is on a broker number 9. But when you are running your code at that point in time, the broker number is 9. 9 is down, right? What Kafka will do? What Kafka will do?
Promote the leader to some other partition.
Exactly, right? So here is a Kafka and this is your broker number 9. And here is your partition 0, which is the leader here, right? But we know partition 0 has a follower partition also, right? Which is up and running. So what is the repetition factor here? Repetition factor is 3 here. 1, 2, 3. This is the leader partition. And my producer is sending a message, but this guy is down, right? So I'll get an error saying leader not available. Very common error message, right? So in the meantime, quickly producer will retry that message. So by that time, Kafka will make this guy as a leader, right? And then producer will be able to push those events again. Okay, so, but if you are sending a message, now this is a retryable errors, right? This is something you can keep on retrying. No, no problem there. But if you are sending a message of 1 to MB here, right? Doesn't matter how many times you will keep on trying, right? So you will keep on getting the error. You cannot send a message of 1.2 MB when things are configured for 1 MB only, right? So Kafka has clear, idea what are the errors or where we can retry, what are the errors where we should not, no point in retrying, right? So if you have this kind of error, Kafka will not retry. It is a kind of a non-retryable error and things will fail at your end. Okay, any question here?
Shrikant, one question here.
Yeah.
So like you said that the leader will be promoted, right? So right now, can we see this in action, like like after we shut down broker 1?
Yeah, you can do that. You can do that, right?
And
so
still
right now we have you have 3 brokers, right?
Correct.
So you can use a describe command. Describe command will tell you where exactly your partitions are, right? Where is the partition 0, partition 1, partition 2, right? And here we have a leader, right? So you turn off any one machine and then try, right? So again you after shutting down one particular service, right? You can again describe here. You will see that the leaders have changed from 2 to 1 here, right? Let's say situation was like this, right? And you shut down this particular server here, right? So what will happen here now? This will be something like this.
Well, yeah. So that too, I think we saw yesterday. What I wanted to know was if my producer still produces it, will the consumer get it? Or because now you said that the producer will try, and if the producer doesn't get like an acknowledgement that it has been successfully received by the broker, so it will keep retrying. So for that, we have to configure the code.
No, Kafka will take care of that.
Okay.
Right, what you can do here now, guys, see now, if we cover all the aspects, right, it will be time consuming. There are so many things to cover, right? So I would suggest you, so when you're producing, you have a for loop, right? You have a for loop, add a some kind of sleep here, right? Maybe you can put a timer sleeper of maybe 5 seconds here, right? And meanwhile, when things are going, producing messages one by one to Kafka, right? Meanwhile, you shut down this machine, right? And you also keep on running your consumer, right? Even if your 2 is down, right? Consumer should be able to consume all the messages, right? Put a timer there in the for loop of your producer. So slowly you will produce, and immediately you can stop this 2 also here. Broker 2, broker 3.
Sure, Shrikant, I'll try that.
Yeah.
Thanks.
Sure. Okay. Go on mute. Okay, any question here, guys?
Yeah, Srikanth, one question. So we
Yeah.
have like broker leader as well as the partition leader, right? So can it be possible where the broker leader and the partition the partition leader is on the same as the broker leader, and
Okay, there is
the
no broker
broker leader
leader.
goes.
There is no
Okay.
broker leader. Is a partition leader. Partition leader on some broker.
Okay.
What is the confusion? You explain.
No,
Me.
but if like one of the broker goes down, so again it like Kafka like promotes that broker to some another like broker which is available, right? So I thought that there might be like broker leader as well as the like follower leader, and if the broker leader goes down, I was like thinking in that way.
No, it's not
Maybe I
like
am wrong.
this. No, it's not like this, right? So basically, whatever the leader partition, see, this is the topic 1, right? This is topic 2. This is topic 3, right? And this has 2 partition. This has 3 partitions. This has 2 partition, right? So here T1, 1 partition, right? T2, 1 partition is coming here, 1 partition is coming here, 1 partition is coming here, right? And then T3 is coming here and coming here. Are you with me?
Yes.
Right? Now, if this broker is going down, right, these are the 3 leader partitions for the 3, assuming, right? All 3 leader partitions coming on this particular broker, right? But we have a follower partition here. We have a follower partition here, right? And we have a follower partition here as well, right? So it is the responsibility of Kafka to make them leader. So understood, right? So even if this broker goes down, no worries, right? So we have, this will help you only when you have a replica in place. If you have one more topic, T4, and one replica only, right? If this broker is down, there is no way, it's a data loss for you. You won't be able to produce now because it's the only one replica. You don't have another replica, and Kafka cannot make that replica a leader partition, but does not exist there. Right? So it's not a leader broker, but yeah, all the leader partitions available on that broker. If you have replicas in place, more than one, then as a, Kafka can help you to make others replica as a leader replica, and you will keep on producing events to those replicas now. Clear now?
Yes, clear.
Okay.
Thanks.
Shrikant, one question on this diagram.
Yeah.
Can you go back to your slide, please?
Yeah.
Yeah. So previously you were mentioning that while creating the topic, we can mention the partition number as well, right? So suppose like if we are not
Hold on. While creating the topic, we can specify the number of partitions, correct?
Right. And on which partition we need to publish the messages, that also we can mention.
No. While producing, you can specify that I want to produce to particular partition. That is possible.
Particular partition, correct.
Yeah.
Now suppose this batches, like how Kafka, when Kafka is going to create the partitioner by itself, that wanted to check.
Come again.
So here in this diagram, we can see like as soon as we hit the send button, then it is going to serialize, right? Based on that key serializer and the value serializer, which we are going to mention. But when the Kafka is going to create the partitioner for the topic A and the topic B and put those batches, that I wanted to understand.
Okay. See, basically, as a part of send method, serialization is simple. Right? I mean, irrespective of to where it is going and to which partition, everything will be serialized. And later on, Kafka producer has to decide to which partition. Now, if you are using that property to specific partition, right? So these things are not coming into picture. Now here it is a generic one, right? So if you are passing data to all the partitions one by one based on the key, so based on the hash code, it will decide whether this particular message will be a part of this batch or this batch. Now this batch is for a partition 0, this batch is for a partition 1, right? Now how you're deciding here, let me copy this quickly here. Okay, so now you see a message as a C100, right? And here your remainder is basically say 0, right? So we know this particular message will be part of this batch, right? So C200, this message will be part of this batch. So this will go on. So based on the hash code, we are creating some batches, and all C1, 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 C1 will come here. And by using your IO threads, right, in Kafka, this entire batch will be sent to the Kafka, right? In another batch, maybe you will have a C2, 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 C2 like this. Is this what you're asking, Adina?
No, my question was like, for the partitioner, do I need to mention anything specifically in the code that create this many partition, or the Kafka is going to create those partition, by itself?
When you are creating topic, partitions are already created, right?
Correct.
Right? It is there in some brokers. If it's a
Correct.
3 partitions.
Correct.
Right? So it is already there. Say this is a broker 2, broker 3, and broker 4.
Correct.
It's already there,
That we have mentioned in the upper section of your diagram in that PPT.
right?
That inside topic we have these 3 partitions.
Right.
Now after serialization, we are saying that we have partitioner also.
Correct. Partitioner is basically is not about creating the partitions. It's already created. Partition is something, deciding on the fly that this particular message should go to which partition. So one strategy is to use a partition algorithm, which will take your key of your message, mod of number of partitions, whatever the number of reducer whatever the number of remainder you get, your message will be sent to that partition. This is the one strategy. Second strategy is, I don't want to get into this. I want to write my own custom partitioner, right? So partitioner, it means that, what strategy you're using to divert your key value pairs or messages to a particular partition, which is already created.
Okay. Okay, got it.
Okay.
I thought it is another.
No. If we are not creating part, we are simply, using some kind of algorithm to, divert those events to those partitions based on what you are using there.
Yeah.
Okay. So overall, this is how it happens. Producer record, we can produce topic. What is highlighted here is a mandatory. These are the not mandatory, right? So send method, first we do is serialize. Then we need to, use a partitioner, and partitioner will decide which message will be part of which partition 0, partition 1, right? And stuff like that. So, and then some message will be part of this batch, some message will be of part of this batch, right? Then by using your IO threads, things will be sent to the Kafka. Kafka will send a message back to the producer. And if it is failing, yes, can we retry? No exception. If you can retry, yes, again it will try again. If you cannot fail, if things are not failing, then you will get a proper metadata from a broker that, hey, your message is written into this partition, and this is the offset number, and this is the timestamp. When exactly you probably might have sent as a 947, but when I'm writing it, right, this is the timestamp from my end, right? This is what you will get in a record metadata. Okay, clear, guys? Any question here?
Shrikant, just a quick question. So those retries, do we need to explicitly configure those, or
we can configure how many times you want, right? You can give it a big number, but there's a one more property will handle it, so it's not something you will keep on trying, right? So there is some timeout things. So it is configurable basically.
So we explicitly need to configure that, right?
By defaults are there. If you want to override those default in Kafka, all the properties have default values, right? If you want to override, you can always override.
Okay, got it. Thanks.
And when you say retry, you'll keep on retrying, right? But what is the time? What time should be there in between the two retry? How long you should wait and then retry, right? So even for that, how long you should wait before you retry? For everything, we have a parameter there in Kafka. All right. Okay. Fine. So I think let's take a break here and then we'll continue. Now we'll see the details, some properties, some important properties of a producer. And we'll
Shrikant,
understand.
can you go to the previous slide?
Yeah.
Okay.
Okay. All right. Let's take a break.
Pratik here.
Yeah, go ahead.
So once you are back from the break, right? I'll need your 1 minute. Like I'm trying to start the brokers actually. Every configuration is right. Somehow they are still shutting.
All right, share your screen. Share your screen. No worries. With that. Stop sharing. Go ahead.
So the zookeeper and broker one started, but when I'm trying to start broker 2 and 3, they are continuously going into shutting down.
Shutting down. Okay.
So,
Can you show me the error? Can you show me the error? Go on top. Just hold on. ID 1 does not match broker ID 0 in meta properties. Okay. So it's a underscore or -3 in your case. File name. This is file name is fine.
Yeah.
Okay.
I will show you.
Okay. Are you able to run 3 brokers before this, or your first time you are trying?
Yesterday broker 2 was working, but today when I'm trying from the script,
okay,
even broker 2 is not
no,
running.
go to Kafka config and server 1.properties. Server 1 first. Right. So here, go on top. Server broker 0. Just hold on. This is fine. Go to log basics. Kafka logs. Yeah, this is fine. Go to Kafka log basics. No, on top. Just hold on. Yeah, line number 83, right? So Kafka, okay, fine. Go to the next file. 01, okay. 93, this is fine. Go to log basics. Yeah, 01. There it was 01 or 0. Here also it's a 0. Okay, 0. Okay, fine. Here it is 1. All right. And Kafka 294 looks fine. 012. Okay. All right, this looks fine. So do one thing. Close all this. Go to the Kafka. Go to the LSF. Yeah, CD enter. CD enter. थोड़ा विंडो बड़ा कर दो. LS-LTR. Okay, so you delete. Why you have only Kafka logs 1? Kafka logs 2 is there. Why not Kafka log 0? Kafka logs. Okay, so RM minus RF space ZOO tab. Enter. RM minus RF, Kafka logs 2 and Kafka logs 1. Okay, so you don't have any topic now, right? We are deleting everything. All right, and now you start your Zookeeper. You start better. You start from your IntelliJ, no? Things will be a little fast. We don't need to type.
Okay. Yeah.
These scripts are not ready.
Yeah, they are ready.
Okay, so start your Zookeeper now.
Zookeeper is already started. Shall I start again?
We should have stopped this, before deleting that data. Anyway, delete everything. Stop everything. Yeah, and stop all the brokers. Close all the windows. Broker 1, broker 2, broker 3. Okay, just give it 2 minutes.
Pratik, you can right click on.
Just give me 1 minute. Just give me 1 minute. Sorry guys, I was talking to my maid. Yeah, tell me. So now you stop. Okay, yeah. Enter. You cannot run from there.
Create this or shall I start the Zookeeper?
Yeah.
From script?
Hey, do one thing now. No such file. No such file. Home Ubuntu Kafka config.
Is small.
Oh, okay.
No, do one thing. Do one thing. You right click there. You right click here.
Where?
Right click there on that file where I have marked here, right? Right click there. Yeah. Run zk.sh. Yeah, click on that.
Okay.
Okay, remember this. Okay. Now run a broker 1. Your Zookeeper is running now. Now right click on a broker 1.sh. No, you don't.
Okay,
you don't. Yeah, they're in.
Got it now.
Right. You can see broker 0 is running here, right? Then right click on a broker 2 and run. Right. Broker ID 1 is also running. Right click on a broker 3. Okay, so broker ID 2 is also running. It means broker 3 is also running. You don't need to do anything in this window. Okay, I remember this. Okay, now you go to create topic, because we have deleted all the logs, right? So topics are not there now. So go to the double click on a create topic. Yeah, so and hold on, don't run. Which topic it is creating? It is creating topic test 1, T1, right? So rename that to test probably. You can say test. Okay, so partition 3, repetition factor 3, and 9092. Right click there in the same window and run. Okay, you should create a. So everything is running fine now. Topic has been created. Okay. All right. Now you can try
Okay.
your code. You can use the console producer, console consumer first. If it is working, then go to your simple producer and start producing events. Okay. So let's take a
Okay.
break now here. I'm going on a mute.
Thank you. Sorry for taking your time. Yeah.
No problem.
So Srikant, how do we run that shell script in Eclipse? Like I don't see any option to like directly run the sh file in Eclipse.
Okay. Sorry, guys, I got late. Yeah. So let's start. So basically, there are some properties for your when you are writing your producers, right? So these are the some properties you need to understand, and then accordingly you can use it. So bootstrap server we understood, key serializer we understood, value serializer we understood. Okay, so let's go ahead now. Okay, so there are some retrievable errors, there are some non-retrievable errors. I explained you. Okay, now there are three type of producers. There are
Sorry, Shrikant, you're not sharing your screen.
okay. Okay, can you see my screen now?
Yes.
Okay, so I was talking about all those kind of things which we already discussed, right? So basically, bootstrap server is required. Bootstrap server is one you need, right? Let me connect to my local IntelliJ because that is okay. Okay, so you can see here, we have a bootstrap server, right? Bootstrap server, and then these are the bootstrap servers, right? So it's not good idea to define just one server. Okay, now everything is running on the same machine. So what I can do here, I know I'm running 3 servers. So you should have a list of servers. You should have a list of 09093 and 127.9094. Okay, so okay. So if you have, let's say 30 brokers or 40 brokers or 50 brokers, it makes sense to give a list of 5-10 brokers, because when you say 100 brokers, there might be a possibility of a couple of brokers are down. That's perfectly fine, right? So it's a good idea to define a list of brokers here. So if your producer is able to connect to any broker, you will get a metadata. When it comes to producing events, which broker you are looking for each individual partition. Okay, don't look at this code, I'll come to this later on. Okay, fine. So that's your bootstrap server. Your key needs to be serialized whether you're using it as a message or not. Your value serializer. Okay, so there are two type of errors: retrievable errors, non-retrievable errors, right? I explained you this. And then there are three type of producers. One is fire and forget, second is synchronous producer, and third is asynchronous producer. Okay, the kind of a code we have seen, let me go, I'll require this now. Okay, if you look at this, why is a problem now? Okay, this is at the broker level, topic level. Yeah, so what I'm explaining here. Okay, right, so the code you see here, okay, the code you see here is a fire and forget producer. Your producer will simply send a message and will not wait for any acknowledgement from broker. Okay, assuming broker will write everything. There are some cases where broker won't be able to write your messages, but you are not bothered about it, right? Your idea here is to send as much messages as possible. Your your target is throughput. Right? You are not worried about some messages are, not processed, not written successfully at the broker end. So in this case, we'll say this is a kind of a simple producer called a fire and forget, just fire and forget. You are not expecting any acknowledgement back from the broker. So things will be very fast. Okay. We send a message to the server and don't really care if it arrives successfully or not. Generally, messages arrive successfully as Kafka is highly available. Producer will retry sending messages automatically. This is not correct. Producer will retry sending messages automatically when in the first place Kafka producer, so not Kafka, when producer is unable to establish a connection with the Kafka broker. Once the connection is established, and even if the server goes down, it will keep on sending the messages. Understand, right? So it will not try anything automatically to retry those messages, because to retry you should know whether the message has been returned to the Kafka or not, and that you will not come to know if it's a fire and forget. So this is something only initially before you start sending messages to the Kafka broker, or before you establish a connection with the Kafka broker. If something wrong there, then you will get an error message and you will try to fix it, or it will work on it, right? But once you establish a connection, then whether messages are written, not written, will not come to know. Okay. So some messages will get lost using this method, obviously, right? So for example, this is my producer. I'm using fire and forget, right? This is my Kafka cluster, right? So producer has established a connection with the one broker, and then probably it is a loop of 0 to 10,000. You are sending all these messages, right? So now you can try this, after the session. So give me 2 minutes, my dog. Give me 1 minute. Okay, can you hear me?
Yeah.
Right. So this producer is about to send this message, right? But in between, if I stop this broker, right, there is nothing you will get from broker back to producer saying, hello, I'm not there, or some kind of error, or some broker not available. Nothing will come there, right? So it will simply say, you can try this, So maybe you can add some, you don't need to add, but maybe you can add a delay of, you can add a sleep of 5 seconds, and then you stop your server and then see, so you will not get any kind of a acknowledgement from broker. So this is your fire and forget kind of a broker. So here the idea is to have a better throughput. Then in that case you can get. So where you should use a fire and forget, if you are pushing events to the Kafka, where it is like some kind of a log files, where millions of data points are generated from your sensors or from your small some as a part of some transactions, and even if some events are not going to producer, you are fine with that. Okay, because the data points are huge. Okay, so even if in case of this is some failure here, you are fine with that. So in that situation, you will go with the fire and forget. Okay, next is your synchronous. We send a message. Any question here with respect to fire and forget? Right. This is what I explained you. You should try this. Okay, you should try this.
Shrikant, you said that if one of the brokers is stopped now, so the messages will be sent to other applicants, right?
See, basically, so that will happen internally, right? That will happen internally anyway. Say maybe some messages are not written to this because the broker is down. So if you in case have a multiple replica, so in any way Kafka will do that, right? But what if you have only one replica? So there's no way you can, Kafka will make another broker as a leader replica for that partition, because for that topic, there is only one partition. So I would suggest you create topic T1 with only one partition and one replica factor and try this.
Okay.
So if this happens to be on a broker one, you start producing, and then when you start producing successfully, you stop this broker and see what happens. Okay, you can take this as an exercise. All right. Same thing you can try with the another topic T2 with the these things, right? So here it should work basically. Okay, so this is your fire and forget producer. Another is a synchronous send. We send a message, the send method returns the future object, and we use get to wait on the future and see if the send was successful or not. Clear, guys? No? Right. So here when you say send, right, here we have a get. What get is returning here? What get is returning here?
Future object.
Record meta. This is the return type, right? Can you see here? Are you able to see my screen, guys? Am I sharing?
Yes.
So the moment you use get, it becomes the synchronous producer, right? It returns some kind of a metadata. So here I'll say a record. I'm writing the same thing in my same simple producer, right? Ideally, I should write another. Let me do that. Not a good idea to do this. Okay. New class. I would say synchronous producer. Okay. Okay. So here I'll use get, right? And here I'll say that class is a record metadata. And here I'll say metadata is equal to this. Okay. And it expects is you add some exception here. Either you can add here, or you can take this code in and try and catch block. Anything, it is up to you guys. You are Java people. Right? So this is a different kind of thing. Okay. Now, what is the problem here? Okay. So this is your synchronous producer. What happens here? This is a synchronous producer, right? So if we are sending one message to the Kafka broker, right? It along with this key topic, key value, we are sending a future object along with this request, send request, right? And we wait for the broker to respond back saying whether this message was written successfully or there was some exception. Will not go ahead with the next message, right? This is very safe producer. This is extremely safe producer, obviously with the very slow kind of a very minimum throughput here, but this is the safest producer. Now if you are doing something extremely important and every message is important to you, then probably you will go with this kind of a producer. Generally in a production environment, we don't say this kind of a producer, right? Because we just cannot keep things, we cannot hold things for each and every message we are sending to the Kafka. No, that will be pretty slow. Okay, so this is your kind of a synchronous producer.
Now suppose like after hitting the send command, like while writing the message, if we get exception, I'm just referring that old diagram which we were discussing. Then in that case, with the get command, we will be receiving the exception kind of object, right?
Right.
and suppose like if we are not getting the exception and if you are not getting the record metadata also, so internally Kafka is going to retry to push the messages again into the
No, it will
partition.
not. It will not retry, right? In this case, you will get either a metadata or exception, right? So it will not go ahead. What? Let's say I'm a producer and I'm talking to my broker, right? I got a 10 things to complete with my broker, right? So I'll give one thing to broker and I'll say, hello, you work on this. Give me the acknowledgement, right? When the broker will give me acknowledgement, doesn't matter whether it's a success or failure, I have to get it.
Okay.
Okay. Then only I'll send a second. Got it, right? So in this case, you will get that whether it's a failure or success, and then only you will send a second thing to the broker. So it's very slow. Okay, so you can try this running it. Right, we should try with the topic where we do not have a multiple replicas. Okay, that will help us to replicate the similar disk quickly, right? Because if we have a multiple replicas, Kafka will manage things internally. You won't see that, right? So you create one topic where we have only one partition, one replica, and stop that and see what is happening there. Okay. All right, then I would suggest, quickly try this on your own. Create one topic quickly. I think that would be time consuming. You understood this? What is the difference between fire and forget and then synchronous producer? Everyone? Or you would like to replicate this? Guys, answer quickly.
Yeah.
Okay.
Yes.
All right. There are only 2 yes. Very good. Okay.
So in the previous example, simple producer, we won't get any error, right?
No.
Even
Right.
if it fails.
Let's try quickly. Let's create a topic and create a topic T1. I have deleted. I'll keep one partition here and one replication factor. Okay, and create a topic. It's already exists. Let me comment this and describe T1. Okay, so let me delete this topic T1. It's created with 3 partitions. I don't want that. All right, let's create a topic T1 again with partition 1, representation factor 1. Okay. Okay. Why it is not deleting topic T1? Oh, this is Windows. No, I'm using lab only, right? So it's a Linux. All right, fine. So let's create a topic T2 quickly. Okay, topic 2 is created, symbol producer, and go to the topic. This is say T2. Okay, so T2 is okay. Where is T2's first partition? So describe T2. I need to know on which broker, right? So it is available, that partition. So your broker is available on a second broker, right? So leader partition, there is only one partition and that is going on a broker 2 here, right? So what we'll do here now, go to the symbol producer T2 and probably you can add some slight delay here, right? Thread dot sleep millisecond, right? So maybe half millisecond or 1 second. Okay, fine. Okay. All right, so now I'll start publishing these 50 events one after another with the gap of 1 second. Start running this. Okay, do one thing before I start this. Okay, I should put a message there. Sending message. Okay, something like this will come to know. Okay, stop and run. Okay, so we are sending messages. Let's go to the terminal and then broker 2, broker 1, broker 2, right? So stop this broker. Okay, right? It keeps still sending messages. Okay, so broker is down basically. It's sending messages, right? We should put some number there also. I think that's fine. Yeah, right. So let's wait. Okay, so if you start a consumer here, okay, and say topic T2, and let's see how many messages we have here. Okay, so let me go and broker 2, right? I stop broker 1 or broker, which broker I stop? Broker 3, broker 1. I stop broker 2, right? Okay, so since broker 2 is not running, you are not able to consume, right? So let me start broker 2 now here. This is your broker 2. Right, error while fetching the metadata because for a T1 leader was not available, right? Now I started my broker 2 and we know the leader is available on that broker only, right? Leader cannot go on another machine because there's only one partition, right? But since probably, you know, by that time broker might have done with those messages. Okay, so again, let me do one thing. Let me send just 20 messages here and then probably 500 milliseconds. Okay, let's see here. Right, let me see if we see the messages. Okay. Consumer topic T2 from beginning.
I think this consumer is for topic T1, right? So I think there is another consumer open. T2.
No, I mentioned here T2, right? Yeah, right. Can you see here, right? All 20 messages are consumed. Probably, you know, it might be earlier window, but you know, so let me go to the simple producer again and let me put 1000 here. Okay, and so we know it is a broker 2, right? Right, let me go to the broker 2 and stop this. Right, so if you look at this, right, it's still sending messages. There is no acknowledgement from your broker to this particular producer, hey, I'm down, you cannot send, right? This guy will go on. This is the fire and forget. Okay, so it has sent all the messages. So let me go back and start this server again, broker 2. So it might have written some messages on the broker 2, right? For topic T2. So let's see. You know, this guy is still running. 10, 11, 12. Okay, earlier messages only. So some messages are there. We didn't put a marker there, but yeah. So whatever the messages producer could produce, that is something you will be able to consume it. Okay. So that is your simple fire and forget producer, right? Now let's come to this particular producer, synchronous producer. And try producing and try stopping your broker. Okay. So let me put a timer here. Okay. And so now we are getting a metadata, right? So where is metadata? Yeah. So, you know, sending a message number 1. Okay. And then I would like to print that metadata here. Okay. Metadata offset. We got that for that message we are sending here. Right here, I will say offset for the message we are sending. This is not Scala. Okay. Okay. So here I would say offset is one thing, and then partition, right? On which partition your message has sent. So offset metadata dot partition. Okay. Then timing, right? And then offset timestamp. Okay. So basically this is the metadata we are expecting if it is written properly, right? Otherwise you can take in a try and catch block, and you can put exception also there. Okay. So let's try this. Maybe we can do one thing here. Try. Okay. And let's take everything as a part of a try. Okay. And then so whatever exceptions we are throwing here, right? Maybe I can take this here. Catch. Okay, there is a multiple, you can add a pipe here. In case of this exception. Okay. This is my, okay. You require here only. Okay, and then in case of exception, I would like to print that exception as out, and then I'll say error sending message E plus that message. Okay, fine. So this is the end of a for loop. This is the end of a for try. Yeah, right, fine. So at the end, flush and close. Okay. So now let's try this. So right now broker 2 is running. Okay, that is something I can check here. Okay, so I can add one more terminal and I can check. So 1, 2, 3. Okay. All right, fine. So now let's run this. So here also we are putting some delay there. And let's see. This is your synchronous producer now. Okay. So for every, see, it's for every message you are getting the response back from the broker, right? Because this is synchronous, right? Let me go and stop broker 2. Where is the broker 2? Broker 2, broker 2. Let's see. Right. Go to the right. So now, so okay, which traffic we are using here? Test 3, right? So it will handle this. So this is fine. Let me stop this and let's say test 2, T2, right? Because we have a multiple partitions replication, right? Kafka will handle this. Generally, failure will not be there, right? And you will not be creating a replica one. You'll always be creating some more topic, right? So even if one broker goes down, somehow Kafka will manage for you, right? Let me try pushing messages to topic T2. Now T2 is there only available on a broker 2, right? Which is down. So in the first place, we should get a message that is leader not available. Let me check. Okay, it's not able to send, right? You are not able to establish a connection, right? Because there's only one. So go and start your terminal broker 2. Okay. And come to this. Let's see. Yeah, it's sending, right? So let's go back to terminal 2 and stop this. Okay, go to these things. Right, it stopped now, right? So we are putting some error message, right? But you can see here, right? It stopped now. It's not right. Now, if you have only one broker and that is going down, right? So probably so there might be some timeout here. Then maybe let's wait. But you can see here, right? It's not going ahead. It is waiting for the exception. So for every message, sending message 6, the offset of that message is 105, right? In which partition that message has gone to partition 0, and in that partition for that message your offset is this, and this is your timestamp, right? This is the epoch date and time epoch, the number of seconds from 119070. So a timeout should happen there, right? And then you should get some error message here. Let's wait, so let's continue. I'll come back to this. Let's see. But in case their servers are running and then some other error, right, for their message, you should be able to see that message. Now this is execution exception, and then I should have some generic execution also, right? So if that exception is not from this category, we might not see that. I think this should capture this. Anyway, fine. So that's your kind of a synchronous send. Okay. Here we are waiting for every message we are sending to the broker, and then only whether exception or a success will be sending the next message. Okay. Next is your synchronous send. we call the send method with the callback function. Here we are writing with the callback, which gets triggered when it receives the response from the Kafka broker. Understand this. So this is a kind of a typically used in the production environment where it will not hold things. It will not insist broker to send a response immediately for each message it is sending to it. Right here, we'll keep on sending messages, and whenever Kafka broker responds to your request that, hey, we have received, right? So that time your callback will be triggered. Okay, it's not like a future object. So we call the send method with the callback function, which gets triggered when it receives the response from the broker. Whenever a broker is in position to send a response back to the producer, that time this callback function will be triggered. And in that function, if you want to lock down something in case of some failures, you can lock down things, you can log in some file, and later on you can check that log for the possible failures or something like this, and then you can handle it. So here, since you are not waiting for each and every message for you're sending to the broker, right? So whenever the broker thinks that, okay, fine, now it's not something for every message, the broker sometime there might be some delay, right? It's not something. So we should not stop us sending messages. Broker will respond back whenever broker has in a position to respond back to the producer. So that time, what broker is responding back, those things you can log in some log, and later on you can check. Now, when should you go for this kind of a producer? When you need a high throughput. Okay, you're not bothered too much about these failures. Of course, failures are expected here also, because we don't know. We are simply sending messages after messages. We are not keeping things on hold for every message. Okay, understand this. So this is the major difference between synchronous producer and then asynchronous producer. Okay. Just give me 2 minutes. So if you look at this send, where is the send? Okay. Right. So one is get, one is without get, that is fire and forget. Get is basically your synchronous, right? And for asynchronous, give me 2 minutes. Right here, what you can do here, instead of get, let me add one more here, new, and asynchronous producer. Okay, let me copy this synchronous producer. Okay, so here let's remove this dot get thing. Okay, and here second parameter is a new callback, right? And on completion, when I say new callback, right? So here we need to override one method on completion. One completion, what do you want, right? So on completion, you can expect a metadata and you can expect a exception, right? You can write a code here. Okay, So if exception, okay, that is E is equal to null, right? Then null means what? Your exception is null, right? It means that your message has been retrieved successfully, all right? So then you can say, you know, maybe I can copy this from here. Yeah, so this is a record metadata. Okay. If it's not null, means some exception is there, right? So else s out, you know, this one. Sorry, this one. Okay. Okay, this is the end of a record metadata, right? And this is the end of your this. Probably we can remove this. Okay. So just hold on. This is not complete, right? This is very the end of this. This, yeah, after this. Okay. Send. This is all your, I think I'm putting one more on completion is this, else is this, if this, and then on completion, and this is your callback. Producer dot send. We don't need this anymore. Okay, and yeah, this is the end of a for loop. It's there now, right? Okay. Is this fine now? Something is missing. Okay.
So I think it is expecting a future record metadata, like the return type.
Do we have a gate here? No, right? Okay.
You need to remove the try.
Yeah. Let's remove this. Yeah. And so where is the end of this? What we can add here. Okay. Yeah. So basically, you know, so whenever broker wants to send a response, broker will send a response. So in this case, on completion, right? So we can use again the same thing. We can try this. You know, you can use T2 here, and then you can try this. Okay. I'll not run this, but I hope you understand. So let me share quickly a simple producer. You have this code. I'll share a synchronous producer. Just make a note of this quickly. Okay. This is your synchronous producer. Message is too long. Okay. Anyway, I'll share this project at the end of the day. Okay. So this project will be there and all this code will be there. Okay. So you can use that directly. You can use this code tomorrow. Okay. So this is your basically a kind of a, you know, okay. Let me run this. Let me run this. So T2 only. And this is your asynchronous producer, right? So let me go to the, now you see things will be fast here compared to synchronous producer. Okay. There it was sending one message and it was waiting for the metadata or failure, right? Can you see here we got an exception now here, right? Error sending some error here, timeout exception. I told you, right? So after some time we can expect this. So it's failed because there is no broker available for this message. Okay.
Shrikant, one question.
Yeah.
So in the synchronous approach, after some time we were able to get this message, right?
Mhm.
But in the fire and forget approach, suppose like I started my broker and then I executed that producer and then I stopped my broker in between.
You won't
Then
get this. You won't get this. You won't get metadata, even metadata also.
but in that first way, in that first case, fire and forget, my messages will also not be published, right?
Correct. But you are not aware of that is happening or not. You're sending messages, right? Thinking it's up and running, right? But there's nothing back from the Kafka to your things, to your producer. It's a very risky producer, basically. But if you have 3 replicas, then I think most of the time your things will be handled automatically. The problem is only 1 replica. Okay. So let me run a asynchronous producer and you can see the difference now immediately. Okay. So topic T2 and the rest of the things are fine. Let's run this. Broker B2 down. Down, right? Let me start this. Okay. Yeah, right. So it was not waiting, right? But broker will respond back, right? We should not be, say like, no, I'll not go ahead. Send me the metadata. That is not required. We know. So broker has respond back, and that's why you have metadata for all the records you have published to the broker, right? It's pretty fast. So this is something, mostly people will be using. And similar concepts are there at the consumer end also, which I'll not be covering. Okay. So we have a synchronous consumer and asynchronous consumer. Okay. What is required other than this, that is something I'll be covering as a part of a consumer. All right, any question here? Here also you can try stopping your broker 2. Okay. So in that case, you will get a message here that yes, broker 2 down somewhere, so because you are waiting for broker to respond back, though it is not immediately, so but you are waiting somewhere. You will log this. Now here we are logging only on the console, right? But you should log this in some file as a part of your application. So in case if you see that for some reason consumer is not getting some messages, you should go and check this log. What is happening here? What was the problem with the producer? Where things failed? Those things you'll be able to capture here.
Shrikant, am I audible?
Yeah, you are audible.
So I just wanted to know if fire and forget producer, where we can use like if the application of that fire and forget producer, like in real time
जहां पे आपको failure का tension नहीं है, or the kind of data you're publishing is not very business critical, a simple data. So I don't mind, whether it is not publishing, right? I know it's a millions of messages we are publishing. So there, in that case, you can go with the fire and forget. But if you have something transactional kind of events where every event is important. For example, you are waiting for OTP to approve or reject, right? Everything is important, right? So then in that case, we'll go with the synchronous and asynchronous. Okay. Yeah, any question?
Can you asynchronous with a large burst?
You're breaking. Try again.
Can you run this asynchronous?
Okay.
Number of
We already run this, right? You can see, right? In a one shot. In synchronous, it was for every message. It was. I'll run synchronous again. See, you'll understand the difference here, right? Even if I remove this, right? I can add this there also, right? But here, your acknowledgement from the broker, you are expecting for every message you are sending to the broker. Right? First message, second message, third message, fourth message, right? So let me stop this. And if you go to the asynchronous, okay, let me add dot sleep.
Shrikant, I think we need to add sleep
Outside,
right?
Yeah. So basically, you know, here because of sleep, this is our waiting. Even if you say here, right, it is
Actually, in printing, it's actually waiting, but all the message is already sent to consumer.
correct, right? So for printing, it is print, you know, it's taking time, right?
After on completion, I think we need to add in line number 17.
Line number
17. Oh, sorry, 37. Yeah, here we.
Yeah. It has completed. It has completed. You got the metadata for all the messages, and while printing it, we are putting a timer there, right? Right. Here also it is taking. So
right now we are getting timer on sending, like after 500 millisecond, it's a sending messages.
Yeah, but see, the idea is basically, you know, here, maybe we can add here then record. But again, for every message, it will wait, right? I mean, so see, basically, if I add couple of properties here, right? So I did not explain those properties, but even if I create a batch here, then you will see the difference. I'll try this, okay? I'll try creating a batches here, and then you'll see, you know, it will create a one batch and then it will send, okay? Okay. Fine. All right, so this is your some properties now, okay? Now, when you are writing a producer, there is one property called Ax. It controls how many replicas, how many partition replicas must receive the record before producer can consider the write was successful, okay? Significant impact on how likely messages are to be lost. If there is one property basically, right? If I can add here, if you go to this, I'll go to this producer only, synchronous. Here I can add one property, props, set property, producer config dot ax config, right? There are two values here. One is all, I guess, all 0 and 1. There are three properties, okay? So 0 means what?
Fire and forget.
Can you hear me?
Yes.
Okay.
Fire and forget.
Yes, right. 0 means no, and not really. But you can say fire and forget, right? So 0 means no acknowledgement from broker. Okay. 1 means what? Acknowledgement only for the leader replica. Okay. I'll explain this here, don't worry. All right, fine. And then all means reconnect. I'm facing some issues. Okay. Replica. And all means acknowledgement for a leader replica as well as follower replica.
So what is the default for this?
Default, I guess, 0. Okay. And by the way, okay. So this is good you asking me this. So Apache Kafka documentation, right? Sorry, 2.8.0. That's what we are using. And go to these configuration. Go to the producer config, right? And Axe, right? So here you can see the default is 1. Default is not all. Default is 1. Okay. And all the details are given there here. So refer that. Let me share this page with you. Okay. Okay. Yeah. So you can specify here, right? So when I say 0, I'm not waiting for an exception, right? When it is 1, you are, see, basically we know, right? So when producer is producing, right? In my producer, I mentioned X as equal to say 1. Means what? Leader, right? You got a 3 replica. This is a leader, okay? Or I would say like this. This is a leader and this is your follow replica, right? Follow replica 1, follow replica 2, right? So if your X is 1, what will happen? You want a kind of a, reply back from the leader partition that, hey, I received this message, right? So this will send a response back to the producer, right? When X is equal to all, then leader will send a message to the follower, right? And it will wait for the acknowledgement from the first replica, and same thing will happen here. Okay. So it is written at the leader, it is written at the first replica, it is written at the second replica, right? And then response will go back to the producer that, hello, not only leader, we have written your data to all the replicas. Okay. This is again, when you want a safe producer, make sure you go with the all, right? This will not show you exact data because this property is linked with the one more property, that is minimum in sync a replica, right? So these two properties work, hand in hand like this. Now, what is this minimum in sync replica? Okay. The right time.
Shrikant, can you repeat this one once again, please? The all one.
So minimum in sync replicas. How many replicas you have? In this case, in the picture you see 3, right? So when I say all, I mean to say based on this. If my minimum in sync replica is 2, then whatever the data you have on this leader replica, right? I must have some replica, okay, which is in sync with this leader partition, leader replica, not leader partition, right? Leader replica. So if you have got a 160 message here, so either one of them have to have 160 messages. So at least 2 replicas needs to be in sync. Okay. Now, if you do not set this property, then what will happen here? You have a leader. Guys, are you with me?
Yes.
Yes.
Let's say in leader replica, we have a 160, right? In leader replica, we have a 160 messages, but somehow here we have 158, here we have a 157. All right, things are not in sync. And now something goes wrong with this particular machine where this leader replica is sitting. What will happen? What will happen next? Anyone? Kafka will make this replica or this replica as a leader, right? Yes or no?
Yes.
Right.
Yeah, right. Now, if Kafka makes this leader as a leader partition, this guy is down, right? So the producer was producing message to this. Now they will start sending messages to this, right? So now when the new message is coming here, what is the offset of that message? 159, right? So here on top of 158, there were two messages which we could not replicate immediately, and something went wrong here. So what happened here? You are losing two messages here. Once you have the new leader, and if you're writing on top of 158, right? So those two messages are gone now. Right? So if you are writing something very business critical data to your Kafka, make sure min in-sync replica is there, right? This is something you can specify while creating the topic. For that topic, then Kafka will ensure, right? So if you have a 160, right? Here it is 158, here is a 157, right? And then you are writing another message. So it will not allow you to write that message until and unless 160 is replicated here or here. Kafka will ensure that for you. At least two, this or this two, needs to be in sync. Okay.
And if we set the property as 1, then this minimum replica is not required at all, right?
No, minimum in sync is always required, right? If I go with the 3 replicas, and if I don't want to elect the unclean replica. So when these two guys are in sync, right? Both the guys are clean, right? But if they are not in sync, then this is like electing the unclean leader, which is not clean like your earlier leader. So if you are writing something, you are not worried about the throughput, you are worried about the events to be written successfully, right? Then you should set this while creating the topic. All right, let's move on. Okay, so that's your X property. Okay, buffer memory. Configures the amount of memory producer will use to buffer messages before sending. Right? If you want to if you want to create a batch at the producer end before sending it to the produce broker, right? So you can set your buffer memory, right? So let's go back to your browser, and somewhere we have that buffer property, right? So buffer memory, right? So by default, it is 32 MB, right? This is a kilobyte. This is this is bytes, kilobytes, right? 32 MB, something like this. Okay. The total bytes of memory producer can use to buffer records waiting to be sent to the server. Okay. So that is something you can configure. You can set the buffer memory. Okay. Now, if the message are sent faster than they are delivered, producer may run out of space. You have declared a buffer memory of 32 MB, right? We are supposed to empty it immediately, right? When you send a messages. But if the messages are being sent to the server with the less speed, or there are some issues, right? So then your buffer will be full, right? You won't be able to push messages to your buffer. Then, right? So we should block some your additional send call for some time, right? So once you release some data from your buffer, so then, then you can use that buffer memory to buffer some more messages. Okay. If the messages are sent faster than they are delivered, see, simple, right? You are buffering at the producer end, right? But somehow you are not able to empty that buffer to the server, right? It means what? The messages are sent faster than they are getting delivered, right? In that case, producer will have issues there. It will run, it may run out of space. How to stop this? So for this, we have one more property, max block ms. Means this, the moment your buffer is full, then this property will come into picture. Okay, just give me 1 minute. Okay, right? So when your buffer is full, running out of space, right? So Kafka will trigger this. It will put things on hold. If the property of this is a 5 millisecond, 10 millisecond, so 10 millisecond, you won't be able to push messages to your buffer. It will wait for buffer to get empty, and then, if you come back again after 5 millisecond, if you still see that it is full, right, again it will block for another 5 millisecond. This way it will have manage those kind of things. Okay, that's the buffer memory. Okay. Another property is the compression type. Ideally wish, anyway, fine. So compression type. Now we know, right? When you are producing, right? First serialize, then partitioning, right? Now here partitioning, here you look at the hash code and you decide whether this will go to the partition 0 or partition 1 or partition 2, right? So when you know all these messages one by one like this, if partition 0, what do you do here? You use some buffer memory, right? And you put all these messages here, which is destined for a partition 0, wherever it is. Okay. Now, once you make a batch of all these messages, we are supposed to go to the partition 0, right? If you want the size of overall messages, when you're sending this entire batch or one message to the broker, okay, so in both the cases, the max size is 1 MB. Remember this, right? Not more than that. So if it's a batch, so let's say the batch size is 1 MB. Right? If I compress this further, so maybe I'll get at least 0.2 or 0.3 MB more, right? So I can add some more messages into that batch, right? After compression. Okay. So that is the advantage of a compression. So when you compress, you can have a big batch, right? So again, the idea is what? To have a good throughput here, right? Retries, client ID, this is at the socket level, right? I think this is, you could be controlled, when you retrying again and again, right? So this is the parameter, it will put things on a hold between 2 retries here, okay? Max in-flight request for connection. Okay. So when the broker is sending events to these partition, this is your broker 1, let's say. So max, what is that? Max in-flight request per connection controls how many messages the producer will send to the server without receiving a response. Right? So here, when the producer establish a connection with the broker, okay, how many messages, max number of messages in flight. Okay, it can be 0, it can be 2, it can be 3, it can be 4, it can be 5. But if you are sending, say, 5 messages, all right, and 5 messages, right? So this message has been written successfully. 1. This message has been written successfully. 2. The offset is 0, offset is 1. And while writing 3, there are some issues, right? So 4 you are able to write it successfully, and 5A are able to write it successfully, right? So obviously you could not write here, so this is not coming in picture here. So offset 2, offset 3. But for this 2 message ID 3 here, it is going back to the producer. Hey, this is something failed, right? So meanwhile, producer has produced a 6, 7, 8, 9, 10, right? So you have this 6, 7, 8, 9, 10, or maybe just before sending, if the producer is taking care of these failed messages, right? So maybe you have 3 here and then 6, 7, 8, 9, right? So when you have the more number of messages, max number of message in flight, more than 1, then things might go out of order. Actually you are sending 1, 2, 3, 4, 5, right? But this is something failed here. So what will happen now in the broker? If you look at this, this will go, this will go, this will go, this will go, and then 3 will come, and then next batch. All right, like this. Okay, but the Kafka is saying, the new Kafka, even if you set 5, right, they will take care of order properly, right? Internally they are managing it, right? So maybe they are tagging some numbers there, right? But the Kafka ensures that, the new Kafka I'm talking about. Okay, so that is your max in-flight request for connection. Request timeout MS controls how long the producer will wait. You remember we got a request timeout, right? I stop my broker 2, and I guess during your synchronous producer, right? I told let's wait, we should get a request timeout. This is the property. How long you should wait for the broker to respond back to the producer, right? You can set this property. Okay, max block MS we already discussed here. Okay, max request size. What is this max request size? 1 MB is the max size of your request, what you are pushing it to the Kafka. We can increase this. Right? But ideally, Kafka is not something for sending a big file or big data or big records, something like that. Kafka is typically used for a small data sets. But in case if you have a message of big file, for example, right? For example, you have a S3. Now, I assume everyone is comfortable with the AWS S3 bucket, right? You are uploading some big files here, right? And the moment you're uploading files on S3, you want to send that data to the Kafka. Now, this file is maybe around 70 MB. Now, I cannot push this one file as a message to the Kafka. I know that, right? But what happens here when S3, we got a URL here, right? URL file, and this URL is tiny here. So instead of sending this file, what we can do here, we can send URL as a message to the Kafka. So the consumer who is consuming this event, right, here also you are getting the URL, and use URL and take the data from S3 directly, right? So in case if you have a huge data and you want to use Kafka, this is the solution for that problem. Okay. All right, I think let's take a break here. Okay, fine. So then serializer and deserializer, I'll explain you. Okay, let's take a break of 45 minutes. So it's 1:15 now here. So see you at 2 o'clock. Our session is 2 o'clock or 3 o'clock? 3 o'clock, right? Yeah, okay, see you. I'm not putting a timer there. I'm stop sharing. So see you at 2 o'clock, guys. Any question before that? Anything with respect to what we have seen so far?
So we will just covering the consumer part also, right? How do you handle
Yeah. We'll quickly complete this. I'll not be covering everything because there are a lot of other things to be covered. So we'll write a consumer code also today, and properties probably we'll see tomorrow. It's some property, okay? And then will move to some other streaming APIs. Because consumer we don't use. Consumer is very simple set of APIs. It's mostly streaming APIs.
Okay, maybe I'll ask my question till when we start consuming.
Fine. All right then. See you at 2 o'clock. Okay, can we start? Guys, are you back? Can we start? Yeah. So Tina is there.
Yes, sure.
Okay. All right. So let me share my screen. Okay. So we talked about this. Now there is a concept of a serializers and deserializers. Okay. You can write your own serializer. Writing serializers. Sorry, my tongue is bit. Okay, so writing serializers a bit tricky, because today you have maybe 2 fields in your class as a part of a pool, right? But you will keep on evolving it. Generally, your schema keeps evolving, right? Based on the some new things or maybe new rules and regulations from government, right? All the time your schema will keep evolving. So when your application is running on at a several places, right, it's difficult to manage this on your own. Okay, so you can write your own serializers, or we have readily available serializers like JSON serializers and Avro serializers and protobuf serializers. Okay, so these are the very famous and then widely used serializers. You don't have to write much code, and you just keep on evolving your schema. Whenever required, you can change the schema, but the serializers will take care of managing those changes in your schema on its own. Okay, so you don't have to tweak your own serializers. Okay, you don't need to write your own serializers. So there is something we'll see. Okay, first of all, let's understand how to write a consumer code in the first place, consumer code, and then I'll show you how to write your own serializers and deserializers. Okay, in fact, we'll be using JSON and Avro serializers. I'll show you, and I'll share some example with you, and then later on you are supposed to make changes in that code. Okay, so you should be comfortable with this serialization and deserialization. Okay, so I'll not talk about this. This is something writing your own customized serializer. So we are not doing it, and no one does this. Now there are two. What are the challenges in serializing? Okay, I think before this, let's complete a consumer code. Okay, so let me go to this. I should have created all right. Okay, fine. So but here I have this code ready, but I'll write a code for you. New class, let's say simple consumer, because okay, yeah, you were saying someone was saying something here.
I don't know why I'm not able to copy that password today.
Yeah, even I'm also facing the same issue. So you can it's basically CLOD capital and Kafka's 4 character lowercase and $1.
Capital C, right?
Capital C, capital D. That's what we have in caps. CLOD and Kafka's first 4 character and then $1 should work. So if you want, you can also write code along with me. We'll go together. Okay, I hope that's fine with you. I think it's not working. Let me close this window. Let me go to this window and stop. I might get error here. Yes, click on this. Right, take me home and sign in. Start.
It is not taking that password, Shrikant.
Try again. See, I think some of you have faced similar issues, right? But later on it worked. It's a CLODD.
Yeah, I tried the same one. Let me start the lab again.
Yeah, let's do that. So okay, so now you can see my screen. I hope you are able to see my screen. So let me start my IntelliJ. So maybe we can do one thing. You can create one more package here, right, on top of com.examples as producers, and you put all these producers there here, okay, and then you create a one more package, consumer. Now it's more organized. Okay, I'll put all these three producer therein, producers. Let's wait, it's indexing. I'll be sharing this entire project, Pratik, after this session. Okay, so I'll be uploading, do one thing, I'll be sharing my PDFs and this is code and some example I'll explain you today. You need to write that code also on your own with some other example. Okay, so So today by this session, at the end of the session, you should get all these things. So I'll be sharing one location. I think let me do that right now. I stop sharing my screen for a minute. Just give me 2 minutes. Where is that now? Is it working, Tina?
Yeah.
Okay. After restarting?
Yes.
Okay. Just give me 2 minutes. 2 minutes, guys. I'll create one folder for you people and then I'll share the link. Okay. And then later on, I'll upload all the documents we can download from there. 'Create folder as TR. Okay. I'm sharing one link. Can you please someone try opening this? For I'll upload one document there. So I created one folder as CLI. All the CLI based commands are there. So are you able to access it? I uploaded all the files there. Please confirm.
Where you have sent the link?
On chat box.
I didn't get your message.
Yeah, it's not there in the chat box.
Oh, is it? Just hold on. Maybe might not have sent to them. No, I shared. Okay, to only Pratik. Sorry. Yeah, try now. Sorry.
Sultan, there is asking for access.
It is asking for access.
Yeah.
Okay, just hold on. How can I get a link with, no restriction? Copy link. Manage access. Restricted anyone with the link. Copy link. Okay, here you go. Try now. You should see two folders now, CLI and docs. So for now, I uploaded only one doc there. That is the first module. I am uploading producer module 2. Are you able to now?
Yeah, very
Okay,
good.
right. So this is something, I'll uploading project today. What I'm writing here, you should get that project at the end of the session. Immediately I'll upload that. Provided I should download it from lab. It should work. No, that should not be a problem. All right. Fine. Let me share my screen now. Before this, let me close a couple of things. Okay. CLODKF KAF K $01. Okay. All right. So here I'll create one package as a producer. Okay. And I should move all this. Okay. Now, simple producer. What is this? Okay, this is different actually. We have written a couple of. This is another project or what? Code. No, this is lab, right? So, okay, here, sorry, yeah. Okay, let's move to this package, refactor. Okay, and I'll create one more package here as consumers. Okay, right here I'll say simple consumer. Okay, fine. Now you can also write along with me, okay guys? So so when you start your console consumer, what are things you need? Tell me. What are things you need? One by one. You need a Bootstrap server, right?
Yeah.
For what purpose you need a Bootstrap server?
For listening to the broker and topic.
For listening, okay. Okay, who would like to add here? Who would like to add here?
That's the primary server that we are trying to.
Basically, for a given topic, right? Because every consumer is consuming from some topic, right? So where are those partitions, leader partitions of that topic, right? So that metadata will come from any one broker. For that purpose, it's a Bootstrap server. Okay. Second, a topic name, right? What else? Right. Primarily these two. Okay. So you can start writing code here and then share with me. Okay. I'll wait for you to complete the code. Everyone.
Hey
start.
Shrikant,
Yeah.
can you repeat again why Bootstrap server is needed?
Why bootstrap service? Why bootstrap service is required for a producer? If you say in every producer, even if you go to simple producer, we have a bootstrap server, right? Why we need this?
Because topic resides in a broker.
Correct. But this broker is the broker one, right?
Yes.
The topic you have created, the topic might be topic under there are only two partitions. That first partition is on a broker number 4 and partition 2 is on a broker number 5. So ideally I should specify broker 4 or broker 5, not broker 1, right? Right. But when we create a broker topic on the Kafka cluster, right, that information is shared with all the brokers. So if you connect to any one broker before you start producing, right, you get all the details of that topic. Even if you are connecting in the first place to the broker 1, you will get the metadata, and when it comes to sending the data, right, so that time we know where we are supposed to send the data, broker 4 and broker 5. Same thing with the consumer, because consumer needs to consume the data. So whether you are producing it or consuming it, what comes in picture? Leader partition of that topic and where it is. So we can start communicating with that directly. Clear now?
Yes.
Okay. Let's go back to this. So you start writing the code, right? So first of all, maybe you can say string topic name S3. I don't know what topic we are using, but that's when we'll figure out. Okay, the next properties. Okay, props is equal to new properties. Okay, then props dot set property. Okay. Now there it was producer config. यहाँ पे क्या आएगा?
Consumer config.
Consumer config, that class is there, right? So first is basically a, all these properties are in a caps bootstrap server, right? Now you know what goes here. Localhost 9092. Ideally you should provide a list of bootstrap server, because agar 9092 is down, you won't be able to, you know, consume any message. Localhost 9093. Okay. All right. Next property. Next property. Check your producer code and tell me what should be the next property, guys.
Serializer.
Serializer or deserializer? Deserializer, right? So for what key or value? For key, right? So it's a key deserializer coming here because you're using consumer config. Consumer config class doesn't have that parameter key serializer. It's a consumer. So obviously consumer has to deserialize it. What producer has serialized, right? So here we are using a string deserializer. Okay. Class and dot get name. Okay. Then next props dot set property dot consumer config dot value deserializer. And here also let's keep same string deserializer dot get name. Okay, what next? Right, there's a client ID, right? Props dot set property, right? Consumer and then client ID, right? Who all those clients who are consuming these events, right? So this is something not required, but for tracking purpose, it's good to have, right? So I'll say maybe application 1, right? Application 1 is the one who is consuming. You will have some proper application name, right? So those are the application consuming events from this particular topic. You can, you know, all right. Then next, set property. So when you consume, right? If you look at this scripts here, if you go to the consumer, right? What is this? This property is also coming into picture, right? From beginning, right? So let's see What is that property, right? Consumer config dot reset auto offset reset, right? I think this is the property where the value is earliest. Okay, let me check that value. I'm not sure. Consumer config key serializer bootstrap fetch minimum bytes group ID. What is it property? Auto offset reset, right? One is earliest. Auto offset reset. Auto offset reset. I think we are good. Auto offset reset, and then values are earliest, the latest, and then some other values there. Okay. Okay, I'll go with the earliest. Okay. Anything else required here, guys? Who will answer me? This is something important property we are missing, guys. Here. What is
Group.
that? Yes, group ID, right? Let's call it GRP1. Okay. Fine. So this is all properties you require. Now let's create a Kafka consumer. Kafka consumer first. Okay. All right. So I'll use a Kafka consumer, which is consuming string and string. Okay. Let's call it consumer is equal to new Kafka consumer. Okay. And here we'll provide a props here. All the properties Kafka consumer will require to get a connected with your brokers. Okay. All right. What next? Right. Then what you need to do? You need to subscribe to a topic, right? Subscribe to a topic. All right. So here I would say consumer dot subscribe. You can provide the parameter also or collection also. So I'll say collection dot collection dot singleton. Okay, and here I'll provide the topic name, right? If it's a single instance of your this, but you can provide a multiple topics also. Okay, so we are done with the subscribing to a topic. What next?
What is this auto offset reset config?
Auto offset reset config, right?
That is from
Basically whether it's like a from beginning, right? So here we are saying from beginning, if you remember that parameter. From beginning. If you don't mention this, then by default it's a latest one. It will not pull all these old messages before you start your consumer. After starting your consumer, if producer is producing new events, then only you will be able to see those messages. So that is auto offset reset. Okay, anything else? Okay, subscribe to a topic, subscribe. Okay, what next? Then you need to start consuming the messages, right? Consuming the messages. Okay, how? Now, I can say consumer records. Where is the records? Here you go. Consumer records, okay? And of type string, right? That's what we are expecting, right? So here I would say records. And then here I'll say consumer dot poll. Every 100 millisecond, you are polling messages from a Kafka broker, and that will get a couple of records. So here is a collection of records, the records. Okay. So, and then here I will say for a record from records. Okay. What is the type of record here? What do you think, guys? You know records. Records is a collection of what? Consumer, whatever the records is coming key value pair, right? Is a collection. From that collection, I am fetching each element, each key value pair one by one. So what is the type of this record now here? Anyone? It's a consumer record, not records, right? This one. Okay. All right. So here from that consumer records, we are fetching one record. Okay. And then what? Some kind of a printing, some either typically we are doing some processing here, right? We are processing here, but you know that logic is not important. Concept is important here. So we are not processing, but right. So a record dot, you know, offset. Let's print this. Then record dot key of that record, what you are consuming. All right, then record dot value of that message. Okay, then record dot partition, from which partition that record is coming here, right? So okay, so here I would say key. Okay, then value. Okay, and then partition. TITION. All right. Anything else here, right? And then, so everything can go in a try block also. Okay. You can add a catch also there, but here I'll add finally, and finally I'll say close the consumer, and then consumer dot close. Okay. All right. Is there any error? No, right? Topic we are using is what? Test3. All right.
Shrikant, line number 42, you have mentioned records.
42. 42.
Is it supposed to be record, right?
Yeah, thank you. Thanks a lot. Why it is not coming? Partition. All right, thanks a lot. I appreciate that. All right, so now what do you think here? Is this the correct code or is something is missing here? With this code, okay, I'll show you. Let's run this code. So before I run this code and we talk about this code, right? Let's complete this quickly, right? You create another package consumer here, and then let's add a simple consumer and complete this activity quickly. Those who are very new to this, I suggest you write down this. Those who are very comfortable, I am sharing the code with you. I'm not sharing main method, right? You create a main method and inside main method, you put this code. Message is too long. Okay, so I'm sharing in two chunks. Line number 29. Right after line number 29, a remaining code is going there. Okay, go ahead.
In the Bootstrap server config, we can have a single Bootstrap server, right?
Yeah, you can have a single also, right? Or a list of brokers. That's fine. Because agar ek band hai na, so if it is something one is down and then you won't be able to work on. So it's better to provide a list of brokers there on a safer side.
So in the consumer record, if we try to print the timestamp, so will it print the timestamp when the like producer had produced that message?
Very good question, right? So in case if you have said that property while creating the topic test2, right? So whatever the timestamp you mentioned here also you will get the same timestamp. Understood or no? So there's a one property we discussed in the first half, right? If you set that property at the topic level, key, while sending the events, while producing the events, that time matters to you. That time is important to you, right? So when now if you say record dot get time, right? So that create time will come. If you set that property to 1, that is a LAT, log append time, right? When you are actually the data being written to your Kafka broker. So if you set that property to 1, then when you consume this record and if you look at the timing, you will get a LAT. Got it?
Yeah. So basically, what timestamp we set during producing, so that same timestamp will be getting here, right?
Yes.
Okay.
We have timestamp here. Okay. If you want, you can print that also. What is the shortcut for formatting your code here? Anyone?
Control Shift F, I think in Eclipse it works. Not sure in IntelliJ.
Should be all control.
Yeah, done. Fine, complete this quickly and let me know. Okay, so now I'm talking about topic test3, right? So go to the simple producer and just to check that synchronous or asynchronous, I change my topic to T2, right? I'll go back to test3. Okay, test3 we are passing string and test3. I hope it is there. All right, right? So let's run a producer. I hope my terminal JPS. All right, nothing is running. So we restarted our machine, right? So it's okay. Let's close all this kind of things. Close all. Okay, fine. So let's start Zookeeper. Always check, where services are running or not. All right, start broker 1. Meanwhile, you complete your code. Okay, so I'll keep my setup ready. Okay, sorry. Broker 1. Okay, so let's check what all things are running. So we have 3 Kafka, we have Quorum Peer main, right? So Zookeeper is also running. And I hope topic is already created. So I'll use the list command and I'll ensure that topic test3 is there.
You have started only one broker, right?
No, I started all 3 brokers, right? That's why you see here 1, 2, 3, 3 Kafka. Okay, so test3 is there. Good. Now I'll produce simple producer. And meanwhile, I'll start my consumer also, right? So my consumer is running, which is pointing to topic test3. All right. So now let's run a producer, simple producer, topic test 3. I'll run this. So I'm using here fire unforgettable, right? Okay. I don't need this. I don't need that much delay here. Okay. So we are running producer. It's producing here. Terminal. Where is my consumer? Okay, let me run a consumer again. So we have produced, right? We have produced all messages. I'm running a simple consumer. Let's see. Right, it should consume, at least one message, right? Now here, this is, let's run this. Okay, it's running and it's shutting down. Okay, so consumer is the application where it should keep on running. It should never stop, right? So here, by writing code like this won't help you, right? So here, I'll say try and continuous loop while true, right? And then I'll do all these kind of things. Okay, so this will go in a continuous loop. You should not go out. Okay, so while true, every 100 millisecond we are connecting to Control Shift L. No, just give me 1 minute. Okay, so this will go in a continuous loop here. So try and I'll take this out. Okay, so this is for loop. This is consumer. This is your while and then try. Okay. Is any wrong here? Something wrong here? So while true, consume and process, right? So this is your end of a for loop and this is the end of a while. So this will continue. Okay, let's run this now. Topic is test 3. Let's try. No, there's the error here, right? Something is missing. Probably main. Okay. Yeah, right. So all those messages, right? So this is key is 3, right? But this particular key 3 is going on a partition 1 and then offset of that message is 52083, right? So there are so many messages in our broker now here. Okay, so try running this. I'll share this code with you from try to finally block. Okay. Yeah, good.
So what was the partitions and the replication factor while creating the topic for this test 3 topic?
Test 3 is 3 partition, 3 replica factors.
Okay.
Here we see that all the messages that are consumed are from partition 1 only.
Mm, we are using key value pair, right?
No, no, I
Yeah,
see
partition
different
2 is
partition
also
ways.
there. Huh?
Yeah.
Yeah. Continue, and meanwhile I'll try to set my WinSCP. Try running. Okay. Your is Ubuntu password is CLODKAFK$1. Save. Okay. Login. Okay, so Kafka training. So this is the project, right? So I'll do one thing. This TR and code. All right. This is the Kafka training. All right. Fine. So I have this code with me, this project, what you see on the screen, my screen, and there are two more projects here, right? So this quickly I'll explain you. Maybe you can focus on just one project. This is something you can focus on maybe tomorrow. Let me know once you are ready with the code and if it is running at your end. If it is not running at your end, let me know what issues you're facing there.
Yeah, it is working.
Cool. Fine. Now for till now, we are working with a very simple message, guys. Okay. So you can see like, I'm passing a key as a string, value as a string, right? But now I would like to pass something like this. Okay. Go on mute, please, guys. I don't have this message right now. Okay. Fine. I need to have that message. All right, fine. So right now, let's say you are working on as a kind of a real-time application, and your key is a kind of some store ID. All right, and your value is a big JSON document, right? Where we have store ID, cashier ID, right? A POS number, then invoice, a date time, all right? Then transaction amount, right? Then the line items you purchase from that store, 4, right? And then whether you're a primary customer or not, okay? Then the details of these 4 items, right? So line items, and it's an array of 4 items, right? So item number 1, the name of the product, the quantity, and then price, blah, blah, blah. This is the second. This is the array here. So this is one element, second element, third element, fourth element. Why? Because there are 4 items here as a part of this purchase from this particular store is a key. Value is a complete invoice. Value is what? Complete invoice. Now, when you want a home delivery, guys, focus here. Okay. If you want, you can go for a coffee. if you want a home delivery, right, only home delivery field will come, right? But if you want a home delivery, another kind of a child object will come here, right? The address of that customer, right? Line item here is at the high level, right? 4, right? But line item itself is some kind of a class. So it's a complex thing. It's not that simple. Okay. So how you will deal with this? Now, when you are producing, when you are consuming, you are not going to send messages like this all the time, right? You are going to send messages something like this. So when you have 100, you know you have used a value serializer as integer and key serializer as string, right? But what you will use now here? Kafka will not provide serializers for you. If it's a primitive kind of a thing, Kafka has those serializers deserialized by default, right? But POJOs like this is something you need to write your own serializer, right? You don't have to write your own serializers. You need to use some default mostly use serializers, but I'll explain you how to do that. And then maybe you can work on this tomorrow in the first 1 hour, or if you complete that activity before 10 o'clock, that will be great. We will save some time. I can cover some more things. Okay, if you are if at least 50% of you are able to complete that before 10 o'clock, I'll really appreciate that. Okay, so at least we can utilize that 1 hour for some other new topic. Okay, fine. So I hope you are done with this simple consumer here. There are some more to it. I'll come to this later, right? Here also we have a concept of a synchronous consumer and then asynchronous consumer kind of a thing. Okay, so we already spent a good amount of time on those concepts when I explained you the producer. Similar things are there, but let's cover some more things. Okay, fine. Now I'll go to my local machine because the lab was not available, and I was trying these things for you guys. Okay, now. Okay. Here also we have some resources folder by default as a part of Maven project. On the similar line of your Java, I believe we got a resources folder. Now, what I'm trying to do here, let me delete this. Okay, right? So if you look at this producer, I am creating one class txn, all right, which has got all this field, right? So txn is one file I have. Let me open this. Okay, something like this, right? Let's assume that you are sending this kind of a value as a one object. Okay, so maybe you're reading one file and you every after 100 millisecond you're pushing all these records to the Kafka. As a practice, you can try this, but right now I'll focus only on simple record. You can use this file, you can push all the events to the Kafka, and you can do aggregations, right? For example, if I load this data into the database, can I say this is the product category, this is the product category, this is the product under that category, this is a state, sorry, this is the city, this is the state, and then the mode of payment, how that person, who is the person, 6742, right? How this person has made the payment, by credit or by cash. This is the transaction ID, this is the transaction date, right? But if I pass something like this, then everything will go as a string, right? So if you want to work at the consumer end, if you create one POJO out of this one string, that will help you to process your data quickly, right? Because it's a integer field, it's a date field, right? Those kind of things are easily available. You can easily process your data, right? Or open a file, customer. Okay. Now, if you look at this, if you look at this transaction data, right? Customer is what? 6742, 69771. This is the customer ID, right? If I go to the customer file and if I search for that, it's a Ruby bowling. that customer 775, right? So the Ruby has done this particular transaction. But when you are expecting this kind of events at the consumer, why consumer can subscribe to two topics? This is the reason, right? Because now one topic is talking about only transactions and another topic is talking about only customer details, right? There you can join both the data sets, right? You can do aggregation as well. Okay, so typically for this kind of a high-end processing, we generally do not use your consumer API. We use the streaming API, right? And that's what we're going to see tomorrow. It's a bit complex. Those who have worked on a Lambda functions, those who are comfortable with the higher order functions, right? Then you will find it very interesting and very, it's a fun working with those kind of APIs rather than writing a code, something like this. Okay, there we write a very different type of a code. If you have worked on a Scala, Spark, and then maybe some other in other frameworks. Okay. All right, so now how to serialize this? That's the question, right? So I'll go back to my code here. Is it okay if I extend this session for 10-15 minutes, guys? Or you have some other commitment?
Okay, from my side.
Can I have quick confirmation, guys?
I have meeting from 3:15.
Okay. All right, fine. So I think it's okay then. It's okay then. Let's complete here because if I start, it will obviously take more than 10-15 minutes. I'll be sharing this code with you. Try to at least open this project. Which project? I'll show you. Okay. So look at producer and go to the resources, schema folder and transaction file. Transaction file has got 8 fields, right? Have you used this plugin by any chance JSON schema to Pojos in your project? Anyone?
Yes.
Okay, very good. If you have worked on this, then you understood what I'm doing here, right? So you just need to define the schema, and when you are using JSON serializer, so this is the syntax that this is the package name, and I want one object to be created of name txn in the package types. Okay, so this types folder might not be there. So when you compile your entire project, types folder will be created, and this txn as an object, right, will be created with those fields and this thing and with this particular types here. So it will generate Pojos for you based on the schema you're defined in this file. You don't have to create a classes there, right? If you go to the types folder, you can see here, right? And the transition. So this is something, auto generated Pojos for you. All Jackson notations are there, which Kafka will use for serializing and deserializing purpose on its own. Right? So there are some classes will come into pictures. AppSerdy here. You are writing your own Serdy, but you are extending Serdis. Serdis is nothing but a serialization and deserialization, which is a part of your Kafka common serialization package here. This code is a very generic, will not change. Whether your schema will keep on changing, even though your schema will evolving, changing, right? Doesn't matter, right? So JSON serializer. So it's a generic. Your JSON serializer, you will be using this while consuming these classes, transaction classes, right? But you are only passing the type generic. What class you will be passing here? The class you are creating, that's a transaction, right? Other things will remain as it is. Same with the serialization here. It's all generic here, right? So no need to worry. Object mapper will take that object of that class and will generate a kind of a byte array for that object, and then things will be, after serialize, things will be written to your Kafka. Okay, so have a look at this code seriously and see how much you can understand. And I assume here at least all these kind of things you are comfortable here. Will not focus too much on this here. This main thing is your object mapper. You can Google on this if you want. But yes, so when you are writing producer, I'm not writing value as a string or integer. I'm using JSON serializer. JSON serializer, right? So you know what is JSON serializer is serializing. If you go to JSON serializer, right? So you know it's a T here, right? And what you are passing as a value here, you are passing value as a TX, and this is something will be JSON serialized. So there are two types of serializers typically used. One is JSON. So if you know the JSON's format, it has its own schema, right? So, and Avro is something a different type of serializer. Anyway, I think let's wind up now. We'll discuss this about tomorrow. Okay, serializer. So here I am writing one class. I want
Shared
you.
this one as well.
Sorry.
The two files which you have shared in the Google Drive. In that one, this project is also there.
No. I need to upload this project. I need to upload this project. I don't remember. I'll check, and if it is not there, so it's a JSON serializer, and JSON is an Avro serializer and deserializer. You will see two projects there. Okay, open those project, and here I'm using Windows. So these are the command here. You need to open one more project what you already worked, copy that scripts folder and paste. If you have this folder, delete this folder and copy that folder from another project to when you open this project. Okay, so these are the Windows things here, because I generally don't open my virtual machine. It's time consuming. All right, so understand this thoroughly here, and then I'll be asking you to take some different fields, right? Maybe employee or student or something like this. Then you'll be modifying entire things on your own. Okay, fine. So that's fine then. See you tomorrow.
Yeah, please upload this one, Shrikant.
Last thing.
Sorry, I'll upload this. Someone was asking something else.
Yeah, so in the simple example, right, where we presented the offset just for the consumption part. So is there a way where we can, let's say there's some issue while we were processing, while consuming. Is there a way we can use that offset and get that particular record back? Like, let's say I got an offset 1, okay? And while processing, there's some failure at my end, but the data is critical and I need to make sure that all records are processed well.
So there are some semantics, okay? At the most, at the least, exactly once, all those semantics are there. You can set accordingly. So
you will be covering those?
Yeah, I'll be covering that. Right? So generally, what we prefer, if we need to reprocess, that's fine, but we should not miss any record. We should not lose any record. Okay, so that's the semantic generally, because duplicates can be handled in your NoSQL database or in a database that can be handled. There is a way to handle this, right? So if you are using Kafka for processing as a streaming API, then there is a item portent consumer as well, right? Which will ensure that no duplicate records being processed. So a couple of things are there to handle this. Okay. All right, guys. Thank you, everyone. See you tomorrow.
So Shrikant, can you also share the other project as well, the Kafka training project?
Yeah,
Drive?
yeah, it's already there. I'll be sharing that as well. I'll be
Shrikant,
sharing all those things.
Could you please also share the drive link as well? I got disconnected.
Okay, just hold on. Let me check now. Where is the drive link? Can someone?
Let me pick.
No, yeah, I have. I'm sharing. Yeah, try now. I think it's going to Pratik only. No, everyone, right? What is this, Tina?
I'm sorry. I think there is some issue with the copy command. Yeah.
Yeah, thanks. I got it.
Yeah, is it working?
Yeah.
Okay.
You can open it.
Cool. So I'll be uploading all the things,
And till what time we'll be having access to this lab, like today?
Till 5 o'clock, 6 o'clock, I guess. You can check with the, I think it's a 5 o'clock.
No, I
Okay.
5 to
think
6.
yesterday I tried to create that program late night only, and I was able to do that, Shrikant.
Okay. All right. So, but I think it should be open till 6 o'clock.
Yeah, like so yesterday I tried. I think after 6 it wasn't working for me.
I don't know. Might be they might not have, there might be some policy they are defined, but maybe someone might have not included in that policy. That could happen. But generally the policy is for 8 hours in a day. You can try if it works is good, right? But then.
Okay. Thanks.
But you can start at 9 o'clock. I'm sure it is there at 9 o'clock. It's available at 9 o'clock. थोड़ा जल्दी उठो tomorrow. Work on this.
Okay. Thanks, Shrikant.
All right. Thank you. Thanks, everyone. See
Thank you.
Thanks.
You.
Thank you.